Right. I'm not sure how many of you have your Kali boxes ready, but ideally, like our second year students should have the Kali boxes ready. So you should have your Kali box and make sure that you have implemented everything that you need for hereafter for very detailed penetration testing, right? Or very difficult sort of penetration testing. Because CTF, there are 37 binary challenges, crypto challenges 50, forensics 50, generic skills 34. Reverse engineering is the next level of binary exploitation, 55. Anyone here who had done at least some of those levels? At least some of those levels? Our OHTS students in the second year, second sem? Supun, you are there, no?
Yes, sir.
How many you have done up to this point, Supun?
On this.
Okay, no worries, no worries. So by end of the sem, you have to finish all this, right? So that's the whole idea. And Chatura, anything that you tried out here?
Actually, I tried out 1 or 2.
Okay, so let's start again in order, and then you all can do the rest of it. Anyway, so I requested you to set up your environment. That's the first. At the same time, let's build a Kali box. I think you all have to have your Kali box. So I'm running it on my VMware, which is VM Fusion. And once you set up your Kali box, so this one is a 64-bit machine, right? So let me start afresh, right? Do we have anything here? Yeah, no. Yeah, okay, there's few files. Let me remove them as well. So I'm starting everything afresh. So if you miss anything, you can simply clarify all your doubts. So only thing that I'm having is the web browser in the second window. Right. So I hope you all can see this. So there's nothing much here. So we'll set up the box as well. I'll explain. So normally what you should do before you start anything is to set up your Kali. Unfortunately, I'm in the SLID network. I'm not running my VPN today, so I can't do apt update, but I have done it already. So that I don't have to do much. So make sure you do a apt update. So I think you all are aware about Linux. So I'm not going, I'm like starting 101, right? So I'm assuming most of you know those things. So yeah, so make sure that you do a apt update. So I'm in the SLIT network, so I don't want to, or they're not allowing for whatever reason to not to update that. Maybe because of the bandwidth issues. Then of course, there are two other options after this. The after update, any point, if you have questions, stop me and ask. If I know the answer, I'll tell you. Otherwise, I'll others can answer, or let's look at the answer later on. Then you have the upgrade, of course, after the update, right? Okay, okay, Supun, thanks. Okay, that's two Supuns, no? Yeah, no worries. Right. So then you can do upgrade. So that is basically installation of all the needed software. And there's another one called dist upgrade. Right? So the one that you are seeing right now. Can anyone tell me the difference between those two? So as cybersec engineers, you need to understand the differences of these two. So let me type this one. So as you can see, if I'm going through this, it will not happen because of the firewall issues, but they're asking to install over 1 GB of archives. So they're asking for it. I'll say no. And I'll show you the upgrade one. This is the dist upgrade, as I can remember. Let me go and check. Yeah, dist upgrade. And let me do the upgrade one, which is a different command altogether. Sorry, upgrade. So as you can see, it's also calculating. It's not the same. It's a bit different. So what is the difference between update and upgrade? Anyone? Guys, quickly like answer the question so we can cover the rest very quickly. So the idea is I'll be doing this series. Even though I have done several lectures, my videos are available in my channel and other places. You guys can start, of course, but this will be continuous, a fresh series. I thought of going from zero to hero sort of videos, and you guys can watch it. Right. So anyway, so let's explain this quickly. Now, when you do upgrade, which is most recommended, don't do this upgrade if you're not really, if you're sure you do it, otherwise don't do that. Upgrade is, guys, basically updating your system with the current software, but they will not remove or what you call as purge the existing other libraries. But in dist upgrade, what happens is they will even remove some old libraries. So as an example, if you're using some Python packages in pip, there are some packages which you don't need right now, maybe a vulnerable package. So in a dist upgrade, which is this command, right? So this command will remove those ones. So the problem now is your Kali box using Metasploit, where you need a particular library, it will also get removed. So suddenly your Metasploit doesn't or started not working. So that will be a bit of a problem. So it's always necessarily important that you use upgrade as much as possible and dist upgrade whenever you really have a need on it. I hope that part is clear. And of course, again, sometimes you can do a purge and remove unnecessary packages. And of course, sometimes when you try to install, you have to add repositories. I'm not going to do it today, but we'll do it stage by stage. So get yourself familiarized with Kali box. So I know some of you have already done this, but if you're not, please do that, right? And when you do exploitation exercises, it's always good to have a very standard setup, right? A standard setup. So I normally would like to use first window. There are desktop windows here. There are keys that you can use to change in between. First window, I would have a terminal running. Second window, my browser. A third window, maybe a file browser like this, right? And then fourth and fifth window, necessarily whatever you want to need, whatever you need. And then, of course, we can do split terminals vertically, horizontally, whenever and however you need it. So it's totally up to you how you use your terminals. But there are these better tools. Most of probably aware of this point. I know some of you are working in the industry and you are working with the, of course, Linux boxes. A lot of people uses Tmux. I don't know how many of you heard about Tmux. Tmux is great because you can open multiple windows, right? Sorry. So, or else you have something called Terminator. So if you have ever used Linux Terminator, so I think it's called Terminator. Terminator for terminal. So if you search for that, you can find it. Yeah. So manage multiple Linux terminals in one window. So yeah, so this is the Terminator. So you can either select something like Terminator, or you can select something like Tmux. So Tmux is, I can do a separation on Tmux, where you can have multiple sessions and you can quickly change through the sessions using something called a particular break key, right? So but set up that environment. So because when you're doing some complicated stuff, it can be always useful. As an example, we'll be using Python at a point, right? So then, of course, we had run Python. So then I can run Python 3 here in right-hand shell. And as an example, if I want to print some A's to do some buffer flow exercises, so I want to get 1000 A's. So yeah, so it's very easy to do it, and I can just copy paste to this side. And if you are interested in doing it in Tmux, of course, that's also possible. It depending on how familiarized you are yourself with these environments. But guys, you need to familiarize yourself if you want to go and do those critical things, because it's not that simple to do some tasks here in Linux 12. So you have to get used to it, right? So hope that part is clear. Right? So make your environment. It won't happen in a single day, so don't worry, but keep practicing. There are so many things to practice from over the wire. I've been saying this for the first year and into even try hack me to hack the box and many other things. So I hope that is clear, right? Yeah. Subhangan, is that okay? I hope you guys are hearing me, right? Yeah. Aprami, all good?
Yes, sir.
Yeah, thanks,
Yes, sir.
guys. Yeah, perfect. Right. So set up that environment as you wish. So don't worry too much because you might need a bit of a time to adjust to these things. But once you're done, set it up or work on it. And the next thing is, again, I don't think I have installed Sublime. Yeah, I have not, so I can't do it now. But next to install Sublime and Visual Studio Code, both are necessary. One thing about pen testing, offensive security, blue teaming, red teaming, whatever, you have to make your notes. So there are multiple tools that you can use. I always say that I use Obsidian, right? So this is my choices some of the time. Obsidian you can install in Linux. So Obsidian is great. It's a graph tool. So you can use Obsidian to do your fun stuff. So that is fine. Or you can use Notion. But in, I think, a lot of, yeah, there are different choices for Linux world. Of course, Vim is a good option. So Vim notes, something like that, notes. Then you can start writing up your notes. That's all good. But having a graphical editor also wouldn't be any harm, right? So, or of course, you have this mouse pad in these days Linux new, so you can use mouse pad. So this is a visual editor. Like a notepad in Windows. So that is fine. You can customize it and you can do fun stuff with this. So it's very much needed. So get yourself, I mean, like, set up to this one, whatever you like, or maybe Sublime or Visual Studio. I think I have my Visual Studio here. No, it should be that, no? No. Or maybe like, I don't like working with Nano. I'm not expertise in Nano in any way. Yeah, so you can use that. I hope that we have Visual Studio here, or Visual Studio Code as we call it. Or some people do use Code. Okay, I haven't installed it. So, and there are so many other tools as well. Whatever convenient, use it. First, start with something. Don't try to select something better, but start working with something and build up your logic. And always document things. Whatever you do, document. I think those are the initial steps. So I talked about few things. If possible, use the desktops. It's easier to work with, and also get used to key commands. If you're using a VM, install VM tools. So I'm using a VM here, right? So I'm using VMware Fusion. So I need to really get the key combinations right. So I'm not going to talk too much right now, but in the virtual machine, there's something called, if it is VMware, there's something called VMware Toolkit, which you should install. Otherwise, there's this key combinations, right? So these are these keys that you can send to. So you have to make sure that you are much aware about these things as well. So otherwise, you don't have that very convenient working environment like in like a normal host OS. I know most of you using virtual OSs to do your pen testing work, and no harm in that. Of course, if you're doing malware related stuff, obviously it's needed, right? So that's always recommended. Right, and make sure the key combinations are there, and also use desktops proper. And of course, you can use a good browser. So highly recommend to use Firefox, but implement and install Firefox Developer Edition, right? So if you go here right now, if I look at about what do you call it in Firefox, maybe settings, not settings. What is exactly? You get the idea, or you can of course put in terminal and get the version information. Let me check. Should be somewhere here. Right click on this. No, they should be here. Maybe settings. You can get the version clearly. Yeah, you have some general information here. So I just want to tell you.
Helps.
Help. Okay, let me check. Help, and is it about Firefox? Perfect. Thank you so much. So now this is called the extended support release, and there are a few other information, and you know that you will always have a lot more newer content in the developer edition. If you go to Firefox Developer Edition, some people, even hackers, try to use the Developer Edition. So there's no harm in using that. I think there can be some vulnerabilities, but it's all right. So try to get the browser Developer Edition. And of course, you are using Burp Suite at given points, because we are not only working with only network connections, we might use web connections, web security. So better to have the Foxy proxy, right? So some extensions are very much needed. I haven't installed it yet. So, but you can install a extension like Foxy proxy, which you can quickly go in between the proxy and the normal layout. Or otherwise, there are other what you call as the other extensions that you need. These are called extensions, right? In the Firefox world. Yes, so you can use them as well. So depending on your needs, you can configure these things. And so install the relevant, so maybe like something like even Rapalizer can be useful when you're doing web hacking, because you need to know quickly what are the technologies being used, whether it's PHP or Node.js and all that. Okay. Thanks, Sivanka. I think you guys have added it there. Yeah. So, and also please remember, I need a lot of help from you guys when you're doing this, because I can't remember everything. So, and of course, I know, as always telling, I know most of the students or the learning partners are much more experienced than myself in some of those areas. So please feel free. So I don't have any problem with that, because I learn a lot from my students. So anytime, stop me and explain that is wrong and better to do it in a different way. Right. So that's all good. So use a good browser. Chrome is fine, or even whatever default installation in Kali is also fine. But rather, I believe it's good to have your own installation. So if you need, you can install something like Brave browser or anything else, or you can have extensions like DuckDuckGo. Whatever convenient you as a hacker, install them. So it won't happen a single day. Don't try installing all these things, start to learn about hacking. No, doing things and accordingly, progressively start doing these things. So don't worry too much. Only thing I would say, when you get a good system going on, if it is in VMs, unfortunately, I don't think you can do it on VirtualBox. On a VirtualBox, you can get a snapshot and keep the snapshot ready or backed up where you have a good operating system like a pen test box. So that is which very much needed. All right, guys. So I hope that second section is okay. I told first about the Pico CTF, and of course, TryHackMe, they have very interesting set of boxes. So there's a track called Offensive Pen Testing. That's probably what I'm trying to do first, which I've already opened here. So there are multiple rooms starting from Vulnerability, Blue, that is the Eternal Blue one, and Kenobi, and then some advanced exploitation options. There's a lot here, and then buffer flow exploitation. Again, there's few. So let me close down these ones, which is not needed. I'll leave it there. So then I can try out other things like Active Directory. So Windows hacking is very important these days, and a lot more. At the same time, if you don't go in a pathway in TryHackMe, there are other boxes like, say as an example, you can go like and learn burp suit separately, Metasploit, very important, Nmap, and even other boxes, Linux fundamentals and like that. So select these things, and if you can pay the amount and get ready with your this thing. And also you have to have a GitHub account. I have said this several times when I'm doing lectures to you guys, and make sure you have right repositories. There's a lot of good repositories out there, and you can go here to my GitHub account. Let me share it in the chat. Whoever is watching this later on as a video recording, you guys can obviously go to my GitHub and then search for CTF-1, right? And this was taken from another guy, so you can go to the original place and get it if you want to. Otherwise, simply just fork this one. So say you go to my one and you have to log in from your GitHub account and simply click fork, and then you'll have everything here. And this is a great resource. Why I tell you, because there are a lot of resources given here in the first, I would say the ICSA front page, we say, right? In this first main.md, you have the details. So as an example, CTF time, Hack the Box, TryHackMe. So Hack the Box is another great resource. I'm going to go through all of these later on, step by step, but let's start somewhere. So the Hack the Box is also great. A lot of people now don't use Hack the Box most of the time because people are so much attached to TryHackMe, no harm. But yeah, this is also there. And of course, I have instructed most of you to do OSCP. And if you want to do that, of course, offensive security, they have something called Proving Grounds. Again, you have to pay like $12 to $15. No, not much of a harm. You can do that as well. And then a lot of people don't know there are other environments other than TryHackMe and Hack the Box. Of course, Pentester Lab is a very conveniently great environment. I've been using it for some time. So they have so many exercises. Most of them are free. Sorry, a lot of them are free, but not most. So as you can see, there's Pro tier, and quite a nice array of exercises that you can do. And I'm going to do some of them. I'm going to like earn some money out of it as well, but putting it in YouTube. So that's my plan. So anyway, you also can do that. And of course, then there are Over the Wire, and there are some other nice places like Rock Emporium. Of course, Pico CTF is one of the top. And there's this old one called Exploit Education. They have actually removed the site, but now we have started on a different place. So they have a few boxes called Nebula. And I think this is the box that is the most famous box at all, called Protostar. If you know about Live Overflow, the YouTuber, he also goes through the complete list of Protostar hackings. So you guys can try it out. And then many more other things. I'm not going to talk too much. And then, of course, all the YouTubers who are doing these things are been listed. Live Overflow is the best, but he's very difficult to understand. John Hammond is, as I'm always saying, is the top among all of them, because he's like conveniently balanced out. And then there are so many other guys as well. And then, of course, tools. Make sure that you're getting familiar with all the tools like Ghidra, Volatility, and Pawn tools. There you're going to learn about Pawn tools a bit. And you can see so many resources. It'll take probably a few years to really to understand what are those only what are these links, right? So probably another 2 years, it's okay. And then, of course, there are a lot of exercises done by this guy. So we are going to start with this as well. Initially, whatever we are doing is in this place called Pawn, and inside that we have something called Binary Exploitation 101. So this is basically we are going to start up with. I'm getting a big sound. Let me mute that person. Yeah, all good. So what you're supposed to do is that's the first step. And then let me tell you what to do next. The most convenient step is go and I think you can clone this. If you want to clone this to your own PC, you need to get the HTTPS. No, you can simply download it. That's easier. Or you can clone it as well. So there are multiple ways to clone. I think you are aware. And yeah, so you can say gh repo clone and you can clone it. Or simply like, you can, once you fork it, you can just download it as a zip. I believe I have done it already. Let me go to this directory. So keep it in the desktop. So yeah, I have the Pawn folder here. Let me check. Yeah, what I'll do is I'll copy the whole thing. Yeah, I have everything here. Let me copy all that into a desktop folder called new binary exploitation series. I'll keep it as BE2. So hereafter, you can name it as you wish. So every time I would go to this BE2 folder, and it will have all the necessary things. So as an example, if I go to CD desktop, BE2, I will have all my files here. Okay, so there are a few files. So all the necessary commands are there in the readme.md, including the things that I explained earlier with the sites and everything. Okay. Any questions up to this point? Any questions? All good? All good, guys? Anything? Yeah, thanks, Sivanka. Now, Niranjan, are you okay?
Okay, sir.
Yeah, perfect. Udana, I think Ramesh, all you guys are okay, right? Okay, so that's basically setting up your environment and things like that. So let's start diving in. So there are multiple ways we can start this, but let's start with the simple example. So I'll go to Pico CTF, and then this one is called Pico Gym. So let's do this. Let's probably let me check. Let me go to Pico CTF from my Kali box. Pico CTF. Yeah, and I think I need to log in. Yeah. Don't know whether I can remember my password fully, but let's see. Oh, okay. No. Let me quickly check. Okay, 1, 2, 3, 4. That's the problem. Okay, that's all good. I believe you guys are also created the environment. So a lot of things here, so I'm not going to worry too much about it. Let me go to Pico Gym. And of course, as you can see, there are 271 challenges here, and there are several events, as you guys can see. So Pico CTF 2019 event, 2020, 2021, 2022, and this red pawn event. And of course, obviously, you have Pico CTF 2022 event. So then what I'm going to do is I can select one from the list, or I can go directly on binary exploitation. So binary exploitation is the one that we are going to start with. Later on, we can move to the rest. And we go to the simplest one, which is there, which is called buffer overflow 0. So we are going to start with something called buffer overflow, and it has some tags binary exploitation, and that's this function called gets function. Yeah. So you can even filter all the challenges with the gets function. We'll come to that a little bit later on. And then, of course, there are some files which you can download. I think I should get them. So let's copy the link. So this one is the program. It's the real program here. So let's do this. Yeah. So let me go here to the prompt and let me check where am I. Okay, so let's go to my desktop and the B2 folder. And okay, so all the existing ones would be in the pawn folder if you copied them. So I'm going to create a new folder here called, okay, let's do this. Go one step back, and in the B2 folder, what I'll do is I will create a directory called Pico CTF for Pico Gym. So all my
didn't understand that.
Sorry about it. So so all my Pico related things will be here. Okay, right. So then create a make directory. So always create a direct structure. This is binary exploitation or binary overflow. Say we can say B over 0, 1. Right. So let's me go there, and then we can start working. So here also let me go to BE-2. So okay, I'm already there. Then I'm going to Pico Gym and buffer flow 1. So I'll be in the same place. That's much easier. But of course, later on, when you go to Terminator or Tmux, you will see that it's much easier than doing this in 2 different ways. Right. So next, there's no files here. So I would like to get that file. So wget is the best option or the easiest option, or there's another one called Excel, which you can use. So let me copy the link again. Right click, copy link, and go back to the shell and paste this here. You also can do the same. Cool. So I'm having a file called vuln, right? I don't know yet what sort of a file is that. I'll come to that. At the same time, there's another file I need to take, which is the source code. So I'm going to take the link from that as well. And then I'll do another wget to get that file as well. So to start with, I have 2 files. So you can see vuln and vuln.c. You can also do the same stuff and get ready. I'll do ls-al. You can see there are some hidden directories, which is quite normal to Linux. What happened? Okay. And then there's a vuln file and a vuln.c file. Both are having read and write permissions for Kali, that is my root user, and the group and the others only read permissions. That's all right. And these are not directories, these are files. So one, of course, a C program. So of course, easiest thing is to open it up and see. I'll use cat for the moment. Of course, you can see a program code here. We'll open it up on Visual Studio Editor or maybe a mousepad. So let's open it up on mousepad and we'll have a look at the C code. Okay, so what I'm going to do is I'll keep it's here in this side. No harm done. Yeah. So keep it small maybe, or maybe like we can expand this. No harm, right? So let's look at this bit later on. Let me minimize it for the moment. And then we always have this vulnerable exe as well. So let me analyze this file using the file command. If you don't know about the file command, always in Linux, what you do is always learn about things when you're doing something. Say man file, it determine the file type, and a lot of other information is there. So you can use some tags like to get do not prepend file names, .c to get some magic information. So yeah, you will learn about these things later on. But let's start with saying file, not the C file, but the executable. There's an executable file here, or exe. Yeah, we'll know it's exe in the Windows term, but this is called executable. So once I type file vuln, right, or vulnerable in short, it's a ELF. ELF is, people who don't know ELF, that's a executable in the Linux world. Linux ELF. So every time, make sure, let me say Linux ELF files, make notes. As an example, understand the ELF file format. So go and read your content. Take it slowly, right? So get some notes about it, and read a bit more and watch a video likewise. So what you should do ideally is, now you get some information, so make some notes. So as an example, I would like to go here and go to my mousepad and open up a new tab or a new window. And I would say simply, yeah, it's good to open a new tab, I believe, if it's possible to do new, no, right? Okay, not to worry. We'll create a new window. Oh, we can do a new tab. And I'm going to explain, we are starting with, I'll make my notes with PicoGym simplest buffer flow. And we need, now we found the file is in ELF format. So it's completely good. It's completely all right to do some further analysis, right? So let's minimize this. And now your file analysis gives out this information. You can do a screenshot. That's also fine. You can do a screenshot like this. And I don't think I can paste it to the mousepad. No, I probably can do it in my Mac machine, but get those, at least those information. So let me get those information at least. So let's edit and copy the selection and go to the mouse pad and paste it. So get some information. I will read it here. So now we can see it's a 32-bit executable, and right, so it's on the least significant bit. So now this is a very important fact. So in Linux there are two byte orders. One is called the most significant bit, and there's other one called LSB. So LSB stands for yes, anyone? Little Indian, right? Little Indian format. So don't worry if you don't understand everything right now. You will learn it day by day, right? Little Indian. And then of course the big Indian. So it's an LSB format, right? And then few other things are there. It's dynamically linked, which is good. We'll talk about it later. And then it's called not stripped. So these are quite good things for attacker. But in modern day operating systems, you never get it like this. So this is a compiled to hack version, right? So but normally, if you look at this executables in newer operating systems, you will never find it like this. So obviously, you can try it out. Like if you go to the etc or bash bin directory, which I can do quickly. Let me ls bin bash. So bin directory. So there are a lot of files here. You can just try it out with file and see whether you get these options. Right. So let me check file. Let me pass a executable file bin, right? And let me get a file like what can be a good file. So maybe you can have something like ping. Do you have any ping commands? I mean pip, maybe that's also fine. It's a Python script, right? So but you have to have executable. So do it, and you will not find the details as simple as the ones that we looked at in our vulnerable file. So that is good, right? So this is the first thing. And of course, there's another program called checksec, which is coming up with pawn tools. We'll talk about pawn tools in a while. And once you check that, yes, so you can see a lot of other additional information as well. So this is NX enable, Pi enable, no canaries. But sometimes we don't like this in this way. So we can disable some of those things to work out for us. So, but don't worry, at the moment, we'll come to that. This is just to understand what sort of a file is that. But we know at least one thing, this is what to remember, this one is a Linux executable. So that will be more than enough for us to start working. But later on, we will understand even how to decode these things and get more information about how to attack these things. Even we have protection. These are called protections. Even protections are available. We know how to hack these things. Right. So now at least now we know there's an executable. Now we know the source code as well, but a lot of the times we don't get the source code, like the CTF boxes and all that. So let's first do something. Now we'll try to run this. Now let me start run this, but this is permission denied. Why? Because this is still not executable. If I do ls-al again, now you can see this vulnerable file is not truly executable for us. There's no X here. See, there should be X here. So what I'm going to do is I'm going to use this command called chmod, and I'm going to add a X, and I'm going to say vulnerable. Right. So now let's see the difference with ls-a. Now you can see, of course, the color have been changed, and then of course there's a nice X here. We love these X's, right? So you don't like X's as it is in the real life, but here you love X's. Yeah. Did I? Okay, thanks. Okay, so now we see it's executable. So let's execute this now, and let's get a bit of a fun. Oh my goodness. So what they're saying, vulnerable, it says, please create a flag.txt in this directory with your own debugging flag. So what happens in the CTF world, there are these flags hidden everywhere. So we need to have a flag truly to read it. And what we do, we'll create a flag, flag.text, sorry, flag, should be flag.text. And we can say, hi, okay, hi, I hacked you. So ideally, I'd read this. For the moment, I don't have a file like that, so I'm going to create one. Now we can see a flag.text as well. Now I'll run this. Vulnerable. Okay, there's input. I can add something like few A's and program exit. So I cannot still go to flag.text. Right? So that is where I need to do my hacking magic. Right? So this is all I know. I can analyze this software, or sorry, analyze this exe or a binary file. That's why it's a binary file, right? That's why it's called a binary exploitation. In later on, probably in the future, we might be able to analyze a quantum file as well in quantum computing. So quantum hacking is also already there. We are now struggling to learn about this binary hacking, which was there 50 years back. Right? So, but yeah, but anyway, we'll learn its structured way where we can do quantum hacking as well. Right. So now I want to go to that flag and get that I have hacked you sort of message, but I can't do it in this way. As you can see, I can give you several A's, but still nothing work. Or I can give like, give me my flag. I can be creative. Give me my flag, but it won't give the flag. Now I need to hack this. Right. So if I hack, okay, up to this point, is that clear to everyone else? Is this clear?
Yes, sir.
Good. Right. Thanks, Supun. Supun De Silva. So there are two Supuns, right? So our usual Supun said that it should be Supun De Silva. Who is that other Supun? What's your surname, Puta? Like from the first sem or second sem? Yeah. Anyway, it's okay. Usually I call Supun most of the time because he's volunteered to be the batch rep for the fourth sem students. Right. Anyway, thanks both of you. Right. So now we need to analyze this. So now the best thing is to now normally please understand you don't get the source code, but luckily Pico CTF has given us the source code. So they are giving it to us, as you can see. And what they're asking us to do is this. Let's start off simple. Of course, the title goes as smash the stack. We'll come to this one. There are books written on this idea called smash the stack. It's called stack overflow, right? So kill the stack or attack the stack. And stack එකට game දීලා අපි hack කරමු කියලා කියන්නේ. Give me a second. There's a student calling. Nadun, you are here? Yeah, but තාම මම lecture එක මම තව පැයක් විතර වගේ 4ට වගේ හම්බෙමු. ඒතර මම ඔව් 4ට එන්නකෝ 11th floor එකට. Hi, thank you. Right. And you can remotely test this as well. මේක මේ all is connected එකක් තියෙනවා. අපිට මේක මේ netcat එක දාලා remotely connect කරන්න පුළුවන්. අපි බලමු එකක් try කරලා. මේ Saturn කියන එකේ තියෙනවා. මම හිතන්නේ සමහරවිට මේක අපි stress එකක් up කරගන්න මේක නම් එහෙම ප්‍රශ්නයක් නැහැ. So hints වගේකුත් දීලා තියෙනවා. ඒක අපිට වැදගත් නැහැ මේ වෙලාවේ. We go back here and we'll try netcatting. People don't know this tool called netcat. It's called the Swiss Army knife. ඒ කියන්නේ ඕනම දෙයක් කරන්න පුළුවන් මේකෙන්. අපි මේ try out කරමු. මේ අර program එකම run වෙන්නේ. So now guys remember what I have done. I have downloaded the program, locally ran it. Now this is a remote setup. Right? මේ server එකට අපි netcat කරලා අපි message එකක් යවනවා. same message එක යවන්නම් කලින් යපු ඒ ටිකම program will exit. Nothing happens. Nothing happens. Hope that is clear. Okay. So I'm not going to work the remote one because I have my files. It's a lot of fun to work remote, locally first. But you will learn day by day how other things comes around. And now I'll look at the code. So make sure you can comment on things. You can say, I have tried running the program. So always make your notes fast. So if you do OSCP exam, this is mandatory, right? Tried changing permissions using the chmod, and you can give comments like it worked, now needs to hack the stack to get the flag. Right. So what is the next step? Next step, let's study the code. So we have the code here. So it's a lot of fun. But guys, okay, let's do this. I'm not going to look at the code. Let's take a blind approach and do that. Okay, let's go here now. Let's minimize this. I don't want that code at the moment. Let's try to analyze this file a little bit more. Okay. Anytime if you have any questions, please feel free to ask your questions. And let me save my mouse pads. Let me save this first. So I should ideally save all my files here. So let me create a folder and name it as docs. Right. So I go inside that. So this is where my not the flag, but truly these are the documentary or write-up. We call them write-ups or walkthroughs. So I'll save it first. And vulnerable C file, anyway, it's not my file, it's already there. So let me close this first. And let me open it in the background. So I'll have my prompt. Okay, so that's the same thing. Right. And let me open up my write-up as well. So both files are there like previous. So I'm good now. Okay, I don't think there's any questions. Let's analyze my file a little bit more. So for that, there's a nice tool called readlf. So I'm going to use that. But before that, of course, you can look at the manual page of it. It's pretty big. So I don't want to go through it now, but make your notes. Later on, we'll learn a little bit more about that. So what I'm going to do is to understand a little bit more about my, a little bit more about my binary, which is vuln. I'm going to look at the symbol table. So let's look at that. So of course, what you are seeing here now, this is where you start to understand how critical or how important to learn cybersecurity, because when you learn cybersecurity, including assembly programming, you will be the best programmer, best network engineer, best DevOps engineer, who else? Best project manager, because no one can basically beat you, because you know everything about computers. So no one can even try to even, I don't know, even tally with you. So it's all a joke, because once you learn this art, it take a bit of a time. Don't get frustrated on any of the things that you're seeing hereafter. What you need to understand is you all can learn this bit by bit. That's what I'm going to do. So nothing much. So let's look at it. So what you're seeing here is a lot of stuff, right? Which we don't need. What we need is, if you go back here to the bottom of it, we see some of those. If you can look at the column names, type, bind, vis, ndx, and things like that. What is important to us here is we need to identify these things called contains, right, or type. So we are looking at some functions. So there's this called func. So you can see func, several funcs. These are called functions. You know, programming, you have functions. Even this is being compiled and put into a binary format. There are functions. එතකොට අපි binary file එකෙත් functions තියෙන්න ඕනේ. ඒ කියන්නේ program code එකේ functions ලියන්නේ. So these functions will be available in, even when you look at from a debugger or decompiler or even a tool like readdlf. So there are some interesting functions. The most interesting function obviously would be main function. At the moment, I don't know how many other functions are there because I haven't looked at the source code, but I know there's a main function. As you can read, it's a function, and there's something global, default. We don't need them up to this point. And then, of course, there's something, it's not a function, but flag is there, but there's no function. And we'll move on. And let me check any other interesting functions here. Of course, there are functions which are library functions. I'm not really worried about them. But then there is this nice function called puts. Puts is a C function, old C function, which is not the best of the functions. And then, of course, there's this dangerous function called string copy. Please, guys, remember, there are several C functions. We don't use C almost all the time for your program, but remember, Windows is written from C language. Linux is written from C language. Mac OS is written from C language. So if C language, wherever C language is used, and wherever there is some C functions, old C functions, that code is vulnerable. So you can hack it. And also there's another function called vuln function. If you check that, that will be more than enough. So there are a few functions here. Some of them are user created functions like vuln and main, and some of them are library functions. So there are a lot here: exit, puts, string copy, and string copy is like a vulnerable function. So there are a few functions that you should be very careful in using. String copy, and there's another function that gets very dangerous, very, very dangerous. This gets function, and few others. So they should be always be taken out from your source code. But unfortunately, there are a lot of written source code in the world which are using these critical functions. Right. So now, up to this point, what we have done, we have used this command called readdlf and had looked at what functions are internally available in this binary. That's all we have looked at. So, and we have learned the main and few other functions are there. And at the moment, don't worry, but I'm telling you, because you have string copies and the get function, this code is 100% vulnerable. So, and now this is where it's good to search a bit. So you can search C gets function, C gets function. Then you'll understand the browsers are yelling at you saying, don't ever use this. It's a very, very bad function to use. Right? It's a normally when you're compiling a C program, it get a warning say not to use it. So get some ideas. Right? So gets puts function. These are very bad functions to use right now. Right? Because the problem I'll tell you, very simple. It's a very simple problem. Let's get the whiteboard quickly. Don't you have the whiteboard here? Yeah, no, right? So it should be available, right? Anyway, it's not a problem. So these functions can overflow the buffer. So we'll come to that later, bit later on. So they can, I mean, they are not controlling the buffer. So we can simply overflow everything. Right, we'll come to that. But now let's move on and see what we can do now. Okay, so now we have already worked with the functions. I know some of the bad functions are there. So what can I do? So let's do this. Right. So now I can, of course, to go beyond this level, I need to do some debugging. So there are a lot of tools which you can use in Kali. There is this thing called debuggers and decompilers. and then the assemblers and disassemblers. There are plenty of tools. Very famous tools are called debuggers. So one of the best debuggers available, any visual tool, of course, IDE would have debugger, where you can put these things called breakpoints and all that. But the most loved debugger by the pen testers, hackers is GDB. Right? So you can type in man GDB, graphical debugger, or GNU debugger. Unfortunately, there's no manual entry for this, and I'm not really sure why. Man 2, man 3. Yeah, no, that's not available. It's okay. It's okay, but because you can always go to the Google and type in GDB. So then you can get into the GDB source code in GitHub, or you can learn a lot more things. So remember, GDB is not only used by hackers, it's used commonly and heavily by developers and system engineers and OS developers and all these people as well. Hope it's clear up to this point. Any questions, guys? Okay, right. So then what I'm going to do is I'm going to run GDB, and then I can run, of course, vulnerable program through this. So then I can go and internally have look at things which are available in the vulnerable program. So let me open this up. So you always get this content, right? So then I can have a look at what's internally available. So I can always clear my active terminal. You can see the GDB prompt is there, but that's it. So we have to now do issue commands to see what's inside this binary. I hope that is clear to all of you. Right? But before I go into that, let's do a bit of a theory. Right? Some of you already know this, but so be calm and quiet and listen to me. There can be few people here who are not really knowledgeable about how the internals works in the computer. Even people who know about this, no harm. Just have a look at what I'm going to say. So let's get a whiteboard. Yeah, let's log in. And they're asking for the 2-factor or 3-factor authentication. It's all done. Let's go to the whiteboard. And let's do 101 on not assembly, truly computer architecture. Right. So it's the easiest thing to learn. Don't worry. Some people assume it's a very hard thing. No, guys, it's stupidly simple. Right. So when you know in a computer, even in grade 10 and grade 9 or whatever, when you learn about computers, you learn that you have a motherboard and there's this very important brain of the computer called CPU. So that's CPU, central processing unit. That's a chip, truly. And then, guys, you will have what? You will have your memory, right? So the memory. So those are the two major ones. Of course, there's another memory called the stored memory, which is like really the hard disk, as we said. I'm not going to worry too much about it, but anyway, remember your software code will be in the hard disk. So what happens is your software code get loaded up to the memory and then used in the memory with the help of the CPU. So CPU is the one truly.
I didn't understand that.
Sorry about it. Yeah, so CPU is the one truly doing all the magic work, but it uses memory, right? So only thing is, this is sometimes difficult people understand. In our brain, we have everything at the same place. If you look at your own brain, brain CPU කියන operation එකයි. At the same time, you have the other operations like the memory, everything in the same hard disk so that is the bit of the illogical thing. But when it comes to computer, these things are three separate things. RAM කියලා කියන්නේ මේකට memory එකට CPU එකේ තමයි තියෙන i3, i5, i7 processors, right? Don't worry too much. There are these things for course, but we are looking at a very high level view, so you don't have to worry too much about this core processing, right? Anyway, so you have the CPU and then you have the memory, and this is called the von Neumann architecture. And guys, there's one thing to understand in the beginning. There's a bit of a problem in this architecture. That is, we can draw a line in between the RAM and the processor. So this is called the IO lines. And the problem is these two devices or these two entities are really fast in their work. but unfortunately, this IO operation is very slow. One Newman bottleneck. We'll come to that. In the newer models, they are trying to remove it. So they will do few activities to change it. Then we'll have faster computers. Okay, that's enough. Now we have a RAM, memory, and the CPU. Now, what happens when you run a program? Say you want to run any program, whether it's your operating system or to a simple C program. What happens is whatever program code that you will write will be converted into a language called assembly language. So assembly is the one, it's called a machine language in a way. So which basically run stage by stage. So I can show you assembly code. Let me quickly take you to my GDB, and I'm going to do a quick thing called set disassembly to Intel. So the most of the computers which are using these days are called Intel based CPUs. Mage me MacBook at Intel based, right? But you know, the newer MacBooks are coming up with called M1 chip or M2 chip, M1 chip, right? And the other one is very famous one is called AMD, right? So those are the two versions. I'm going to use Intel hereafter. So this you can basically add it to the init file to make it permanent, or every time you can type in. Don't worry too much, right? Then you can remember things now. Right, so that's basically the first command to type in. Then which I did in the previous case using the readelf function, if you can remember, right? So let me show you readelf. readelf -s for symbols balanna. This is the exe that I'm running. This is the outcome or output that I got. So you have that. So what I'm going to do now, I have another GDB function. There's a function called info functions. ඒකෙනුත් මේ functions ටික විතරයි පෙන්නන්නේ. අනිත් symbols පෙන්නන්නේ නැහැ. symbol එකක් කියන්නේ මොකක්hari code එකක්. function කියන්නේ code එකක්. එතකොට මට පෙන්නනවා few functions init කියලා එකක් පෙන්නනවා. printf එකක්. ඔන්න gets එක තියෙනවා. dangerous function. මේ gets එක කොහොමද පේනවා මෙන්න මෙතන. තියෙනවා gets එක. කොතනද gets එක තියෙන්නේ? මෙන්න තියෙනවා function එක. හරි? Okay, then we have a few other things like what are the other things? Puts තියෙනවා. Right, string copy එකක් තියෙනවා. Oh, this is the one, string copy එකක් තියෙනවා. So here also you get a string copy. Oh, string copy. Okay, it's here. And then of course the vulnerable function. Okay, that's the cool one. That's a cool one, vulnerable function. Okay, තමයි අපි ඇත්තටම try කරන්නේ hack කරන්න ඉස්සරහට. I will look at it. And what you see මේ බින්දු බින්දු ගොඩක් තියෙන්නේ මොකද්ද? That is something that you have to be knowledgeable. Now remember, we come to this. This is the address of that function. Whatever we run in our computer had to be first stored in somewhere, right? Store in somewhere, and that storage have address. Now, if you have a book, physical book or money, you go and store somewhere. No, like a purse එකේ වෙන්න පුළුවන්. නැත්නම් file cabinet එකේ වෙන්න පුළුවන්. Or even it can be, you know, and the ඇතුලේ කොටයක් ඔතල වෙන්න පුළුවන්, right? So you have address, no, you know how to refer to it. Similarly, whatever code, it's a hacking code, whatever, it has address. Now, these addresses in the computing world ideally refer from hex. Binary what? Right? Binary can 1 or 0. Decimal what? Octal what? Name hex වලින්. ඇයි කියලා අහන්නේ සරලයි. Hex තමයි සරලම. ඔක මේක binary වලින් දැක්කොත් 1010 පිස්සු හැදෙනවා හැමෝටම. So it's not binary. අපි decimal පාවිච්චි කරන්නේ නැහැ because it can be too complex. But hex is the easiest one. දැන් බලන්න මේක hex code එක තමයි 00001353. දැන් මේක 8ක් තියෙනවා. මේක කියන්නේ bytes 8ක් තියෙනවා. ඒ කියන්නේ මේක 4 into 8 is 32 bit ideally, right? So but in the real world this computer is a 64-bit computer, Kali box, so it will have 16 actually, 16 bytes. But it doesn't show the unnecessary ones. So don't worry about too much about those things, but remember there's an address. And when you look at here, what can you say? The highlighted things. Is the same address or two different addresses?
Same address.
Same address. This is the point which is very important, guys. Why it is important? What we are seeing here in readelf is a compiled version of that file. So මේක binary file එක තියෙනවා. ඒක run වෙන්නේ නැහැ හැබැයි. So මේක run වෙන්නේ නැති state එක ගත්ත output එක. But in GDB it's in the running state, but still it's the same address. So But in the modern browser, sorry, modern operating system, this can change. Compile now make address run with the venom video. It will be very difficult for us to hack it. But this is the easiest thing. So we have the same address. So this can be useful. So what I will do now, because it's important element, either take a screenshot or just go to my mouse pad and go to my write up and say, I found an interesting function which can be hacked, and that is in this location. Oh no, sorry, I think I have copied the wrong thing. Let me copy it again and go here and paste it again. So now I know the address in hex. Of course, I can convert the binary or decimal. I don't need it, so I'll just leave it there. 1353. Okay, so now what you can understand is, okay, so you have these functions, right? Now we go back. Right. So now we told there's a memory, there's a CPU, and then there's assembly. So what you're looking at here is, next thing is we're going to looking at here is our code main function, this main function in assembly. So let's do that. Let's clear the terminal. And to do that, I have a command called disassemble, right? Disassemble. What is that? Disassemble. Main function. Now we are seeing is all assembly. Let's disassemble vulnerable as well. Okay. Disassemble. Okay. Vulnerable function. Okay, there are some codes. So what we're seeing here is the pure fun assembly code, right? So this is the Intel format. If I use the AMD, this is a little bit different. Not to worry too much right now. And what you are seeing here is even this code, now it's in the memory. And these are the addresses 1353, 1357, 1358, 135A is කොහෙන්ද තියෙන්නේ? ඒ hex හින්දා. ඒ කියන්නේ 10. So 11. No, sorry, 10. B කියන්නේ 11. ඒ වගේ. So you have the addresses. Internally in the addresses, you have this code. Our C code now converted into assembly code. Push කියලා තියෙනවා, move කියලා තියෙනවා, push කියලා තියෙනවා. And there's another thing called EBX. Don't worry, guys. Lesson by lesson, you will learn. Call එකක් තියෙනවා, add එකක් තියෙනවා, push එකක් තියෙනවා. මොකක්ද මේ විකාරය? Don't worry. This is how everything in the computer, now we are looking at everything to do it in the computers or the phone. This is how it all started. Okay, so I'll give you a few minutes coming up to this point. GDB log vendor, disassemble කරලා බලන්න these two functions. Let's take a 2-3 minutes break. All right, I hope that is okay. But before we go to the next step, we'll go back to our theory section and come back. Right. Now, let's look at this on a very different viewpoint. Now, I told you, can you guys hear me?
Yes, sir.
Hope you guys can hear me.
Yes, sir.
I hope you're not sleeping. Guys, are you there?
Yes, sir.
Maybe I'm not hearing you clearly. Can you send a message if you are hearing me and seeing my desktop?
Yes, sir, we can.
Yeah. Okay, thanks. I don't hear you. Maybe that's the problem. That's all right. Perfect. Thanks. If you can hear me, that's enough. So this is the CPU. So this is where the brain of the computer. But the problem with CPU, it also have this mechanical or electrical or electronics equipment. But the only big problem CPU is having, it can do a lot of processing, but it doesn't have a lot of memory. But it needs memory as well, no, to keep information. Now your brain is so superb, it remembers a lot of things. Image එකක් වෙන්න පුළුවන්, but some of the things it can't understand. If I ask you to quickly, okay, Machan, read all these things and remember, you will not be remembering it unless otherwise you're fully exceptional on your brain power, right? Otherwise, you will not remember it. But if you see a face for a few days, you'll remember it. There are things that the computer's processor can do or your brain can do. Very different activities. So never ever compare it. It's stupid to compare even your brain and the CPU. Right. So, but CPU is very limited in the memory. That's where you have a very big memory given to the CPU or to help CPU. It's called RAM, or the memory, real memory in the computer. And CPU's memory is there are two versions. One called registers. The other one is called the cache memory or the flash memory. So we are not going to worry about this cache or flash. We are going to worry only about registers. Sorry about my typing here or write-ups here. So we use something called registers. There are multiple registers. In 32-bit, there are few. And 64-bit, there are some additional ones. But remember, they have a very limited memory capacity. It's not like 4 GB, 8 GB, 16 GB. So in my computer, I have 16 GB of memory. So that's a lot. So you can store a lot of things. But remember, registers have very limited, like kilobytes sometimes. So these are called registers. So there are multiple registers. We learn about it. So famous registers is called ESP, EBP, EIP, likewise. So this is where when you are talking about 32-bit computers. Hope everything is okay. That's it. Let me check whether I have internet. If it's internet, there no problem. Okay, it's all right. It's a whiteboard issue. Right. So there are some other registers like EIP. So this is how happens. It's in the 32-bit world. In the 64-bit world, the same registers we call as RSP, RBP. Okay. Again, not to learn everything today. So these are registers. And the computer's memory is full of addresses, right? So remember one thing. This is what we have to understand here. Now there are addresses. And that's content. Memory එකේ තියෙන addresses. So there's a space here. මේ space එකේ පළවෙනි address එක මේ උඩම address එක අපිට කියන්න පුළුවන්. මාර 0x කියලා හදන්නම් 0x කියන්නේ hexaring කියලා කියන්නේ. ඊට පස්සේ මම කියන්නම් තියෙන address එක. අපි කියනවා 04යි 1459. මේ decimal නෙමෙයි 1459. ඉතින් මාර 04 හල්ලා කියන්නම් 1459. 1459. ඊළඟ 1456. Sorry. 1460. ඊළඟ address එක. ඒක පිළිවෙල contiguous තියෙන 1460, 1461. ඉතින් එහෙම තමයි තියෙන්නේ. මේක තුනකට පේනවා 1459 ට පස්සේ තියෙන්නේ 1456. 60 නෙමෙයි. මොකද hex එකෙන්ද තව ABC තුනකුත් තියෙනවා. Then 145F ඔහොම ගිහලා 1460 තියෙනවා මේ. ඒක මේ දෙක අතර තියෙන්නේ. ඊට 1462, 1463, 68, 6B. That's 70s. Decimal වගේම තමයි පොඩි වෙනසයි තියෙන්නේ. hex ඉන්න වෙනස් numbers එන්නේ. Hope that is clear. And also, when you refer to this location, inside this, there are some values as well. There are values. So what can be the values? It can be anything, guys. It can be image, or it can be just A's, or it can be a password. It can be anything. Even it can be a code like move this to that, code that. Hope that is clear. So what is going to happen, guys? There are these addresses, and then you need to you have some content. Make content document enemy. Content. So what we do now, we'll understand everything. We are having a source code in our hard disk. We are running our source code. Source code assembly this assembly from the main and this assembly from the vulnerable code. Everything get loaded up to the computer's memory. CPU එක මුලින්ම load වෙන්නේ නැහැ. Computer's memory එකට තමයි load වෙන්නේ මෙන්න මෙතෙන්ට. So now we'll try to draw it up in the computer's memory. Now this is the part that you remember. මතක හිටින තේරුම් නැතත් මතක තියාගන්න. මේ තමයි computer එක memory එකේ තියෙනවා something called a very unique area called the stack. ඉතින් ඔච්චරයි දැනගන්න ඕනේ. තව එකක් තියෙනවා මේ පැත්තට හැරිලා heap කියලා. Don't worry too much. stack එක විතර මතක තියාගන්න. එකම දේ තියෙන්නේ මේ stack එකේ පොඩි අංජබජල් ගතියක් තියෙනවා. stack එක තියෙන්නේ උඩට හරවලා කෝප්පයක් වගේ. ඒතකොට stack එකක් කියලා කියන්නේ you know whatever we put in here right අපි දැම්ම එක මේක ඊළඟ යටින් ඉඳන් උඩට සෙට් වෙන්නේ දෙක. එතකොට අපි අයින් කරනවා මුලින්ම දෙක අයින් කරන්න ඕනේ. ඒක තමයි කියන්නේ stack එකක් තියෙන්නේ. last in first out. This one you have learned. ඒ ටික චුට්ටක් ඇති දැනගත්තාම. එතකොට මතක තියාගන්න මේක තියෙන උඩ යට හැදලා. එතකොට මේ උඩ තමයි තියෙන්නේ high addresses. ඒ කියන්නේ මොකද්ද? ලොකු address එක තියෙන්නේ මේ පැත්තේ. පල්ලෙහාට එද්දි තමයි මේක අඩු වේගෙන යන්නේ. ඒකට යටි අංජබජල් සීන් එකක් තියෙන. ඒක අංජබජල් නැහැ. මොකද මේක තමයි 0.x අපි හිතමුකෝ සරල විදිහට කිව්වොත් එimhe 100. ඊළඟ 101 102 right 103. එතන මේ වගේ වනේ 500 වගේ වෙන්නේ. 500 න පල්ලෙහාට මේක 448 පල්ලෙහාට යන්නේ low addresses. එතන stack එකේ පටන් ගන්න දන්ට කියන්නේ stack එකේ top එක මේක කියන්නේ bottom එක. මේ top එක data පිරලා තියෙද්දි මේ top එකේකට කියන address එක තමයි අපේ address එක වෙන්න පුළුවන් 450. ඒ address එක save කරනවා අපේ CPU එකේ වෙනම registry එක. මොකද අපිට සමහර වෙලාවට connections තියාගන්න ඕනේ. උදාහරණයක් විදිහට අපේ බැංකු වල සල්ලි දෙන ඕගොල්ලන්ගේ right. So you have money in your accounts. So but you have to remember key IDs, no account IDs, no. Otherwise you can't go to the bank and say I want to borrow money or withdraw money from this account. They'll ask sir what is the account ID. So those IDs, keys, if it's a wallet, Bitcoin wallet, wallet address, all this being the registries in the CPU. So there are few registries. There are two registries which are important. ESP කියලා කියන්නේ හැම්මිටම මෙන්න මේ stack point එකට. stack එකේ උඩට. EBP කියලා කියන්නේ මොකද්ද? මේ stack එකේ යටට. ඒක තමයි base point එක. ඒතර සාමාන්‍ය address ගත්තාම ESP එකේ stack එකේ address එක අපි address එක ඇහුවොත් එහෙම what is the address 0x450 මේක 450 address එක ඇහුවොත් why I'm stressing that out, but if I ask what is the content in the address 450, it's something else. Make this can be Lakmar, name Lakmar. It can be Supun, whatever. So අපි අහනවා ESP එකේ address එක 450. ඒතර මොනවද තියෙන්නේ? එක different story. stack එකේ අන්තිමට තමයි Lakmarද. ඊට කලින් දැන් මේ BP එකේ තියෙන්නේ Supun. ඒතර EBP එකේ address එක 500යි. address එක 500 but content එක මොකද්ද? Supun. right. So it was a kind of like ඇයි දැන් මේ මෙච්චර memory තියෙද්දි මෙන්න මේවට විතර මතක තියාගන්න because it's like keys. As I told you. ඉතින් මේ registers පාවිච්චි කරන්නේ මෙන්න මේ වගේ පොඩි gadgetics වලට. තව point එකක් තියෙනවා register එකක් තියෙනවා EIP කියලා. That is what is the next instruction to be executed. Okay guys. This is more than enough to do our hacking. Okay. Tell me if you have any problem. Don't worry, I'm going to explain this again and again in multiple different ways. So remember right now, I'll summarize. CPU එක තියෙනවා, you have the memory. You have storing everything that you do and work with the CPU in the memory. Ideal in the stack එකේ. program එකක් load කරාම stack එකට තමයි load වෙන්නේ. game එකක් ගහද්දි game එකේ major components එක load වෙන්නේ stack එකට. ඊට පස්සේ ඒකෙත් controls කරන්නේ මේක මොකක්ද delete යන්න ඕනේ, මොකක්ද ඇතුළට එන්න ඕනේ. ඒ ටික ඔක්කොම කරන්නේ මේ CPU එක උදව් වශයෙන්. ඒතර CPU එකේ ඔක්කොම activities කරන්නේ CPU එක ඇතුළේ. මොකද යාට තමයි power එක තියෙන්නේ. Memory කියලා කියන්නේ just a simple storage area. When you are running a game, you have to filter things and shoot someone. All the calculations is done in the CPU. You can't do the calculation in the memory. So that's why you need to always direct where is the memory, what you want to get. So that is done by these registers. හිතන්න පුළුවන් මේ හැම එකම registers ඔය ටිකෙන් කරන්න පුළුවන්. Yes, you can. So don't worry too much, right? So we'll go step by step. Right. Any questions up to this point? Chatura, Basit, guys, are you clear?
Yes, sir. Clear, sir.
I think I'm not hearing you guys. It's okay. Oh, I'm not sure what's the problem, but let me check. Yeah, and say anyway, we'll not worry too much about it right now. Yeah, perfect. So let's move now. Now with the knowledge we extracted from the theory, we try to understand things. Now, Of course, now I looked at the code. මේ code එක තියෙන තැනක් තියෙනවා. මේ stack එකේ මෙන්න මේ address එකේ තමයි මෙන්න මේ code කැල්ල තියෙන්නේ. Stack එකේ මේ address එකේ තමයි මේ code කැල්ල තියෙන්නේ. ඉතින් so now this is the stack. නිල් පාටින් පේන්නේ the blue color one is the stack. Hope it is clear. So what I'm going to do is I'm going to type in something called info proc map. The commands gonna body වෙන්න එපා. Okay, I'm not running this now. So I'll run it in a second. Then I'll do this. But before I run this, let me put a breakpoint. Otherwise, make a run will exit. You know, I can the breakpoint at the the best place to put the breakpoint is in the vulnerable function. When the main program make a vulnerable function, call karna me. Eka call karna. I thought I'm a vulnerable function. Ethanat string copy run in a method. I will put to a breakpoint to this location. I can address or I can do something like this very easily. Break. I'm going to put it to the function vulnerable function, WULN function, and location 45 plus 45. So I'm going to use plus 45, and there'll be a breakpoint here. So I can check info breakpoints. So there's one breakpoint in the vulnerable function. So what I'm going to do, let's clear the terminal. This side also I don't need much. Let's make it a fresh. Right. Now what I'm going to do is, right. So now I know a breakpoint. So I'm going to just run this. Oh, they're asking for input. You can remember, even when you run the code here, not in the GDB, but if you simply run this code here, they will ask for input. So I can give 4A's here and it will exit. So I'm going to do the same, but it will not exit. Why? But because I put a breakpoint. At this point, now guys, what's really happening? This program is running in the computer's memory and the CPU. If you try to draw this now in a fresh diagram, this is how it should look like. First draw the memory. Memory ke godak තියෙනවා, but let's try to be very simple here. මේ stack එක තියෙනවා මෙතන. Stack එකේ load වෙලා තියෙනවා අපේ main routine එක මුලින්ම load and main routine එක. I think you will understand why, because last in first out. මුලින්ම යන්නේ main එක. as a main එක load වුණාට පස්සේ ඊට පස්සේ load වෙන්නේ මොකද්ද? You have to load the vulnerability function. ඔන්න ඔහම තමයි තියෙන්නේ. ඔය දෙකම load වෙලා තියෙන්නේ. ඉතින් මේ addresses ඔයගොල්ලෝ දන්නවා දැන්. මේ address එක මෙතන තියෙන address එක අපි හිතමුකෝ we can really write the numbers, but මම දැනට නිකන් බොරුවක් ලියන්න. high address එක 500. අපි මෙතන හිතමු 300 කියලා වෙන්න. පස්සේ අපි high address හරියටම ලියාගමු. Right. Hope that is clear. And the stack එකේ point එක අපි මෙතන දැනට තියෙන උඩම top එකේ තමයි stack top එක කියලා කියන්නේ. ඒක අපි තුමු 200යි කියලා දැනට. පස්සේ අපි හරියව ලියාගමු. හරි. මේ addresses හොඳේ 0x මුලට එන්න ඕනේ. I'm not going to write all that, guys. It take a long time. But මෙතන මම ලියන්න 0x 500, එක 0x 300 likewise. And මේ 500 මොකද්ද තියෙන්නේ? main එකේ පළවෙනි ලියන්න ඕන routine එක. පළවෙනි හැරි අන්තිම එක හරි. Don't worry too much about it. ඊට main එකේ තියෙන codes එක assembly codes එක ඔක්කොම මෙතන තියෙනවා memory එකේ. So now we draw the CPU එක මෙතන තියෙන්නේ. CPU එකේ registers වල තියෙන අවශ්‍ය codes කැලේ ටික. So now we don't need to worry about it. We have ESP, if it's 32-bit, otherwise RSP, EBP එක තියෙනවා. ඒවා ටික අපි පස්සේ ලියාගමු මොනවද කියලා. At the moment, this is the current snapshot. ඉතින් අතන වෙලා තියෙන්නේ program එක run වෙලා මෙන්න මෙතනින් නැවතිලා තියෙනවා vulnerable එකේ එක තැනකින් නවත්තගෙන ඉන්නවා මම. දැන් මට බලන්න පුළුවන් stack එක මොන වගේද දැන් තියෙන්නේ කියලා. Let's go and analyze this. So now you know it's running. එක මේ නැවතිලා තියෙන, it's in a breakpoint. The first thing is I want to check examine the stack. So to examine the stack, there's a command called x. X තමයි command එක examine කරන්නේ. මට පුළුවන් x කියලා /x මේකට worry වෙන්න එපා. x වලින් බලන්න ආසයි මට. කොතන ඉඳන්ද ESP එකෙන්ද ඉස්සරහට. ESP කියලා කියන්නේ මොකද්ද දැන්? I hope you understand. ESP කියලා කියන්නේ top එකේ ඉඳලා ඉස්සරහට කියන්නේ ඇත්තටම බලන්නේ පස්සට උඩට බලන්නේ. හොඳේ. මෙතන උඩට බලන්නේ. ESP එක point කරන්නේ මෙතෙන්ට. Sorry about it. ESP is here, top of the stack. දැන් ඒක තමයි top එක. bottom එක මේක. හැබැයි මේක අනිත් පැත්ත හැරලා තියෙන තමයි පොඩි conflict එකේ worry වෙන්න එපා. මෙතන තමයි ESP එක point කරන්නේ. මම කියනවා ESP එකේ ඉඳලා උඩට බලන්න. ඒතර මුඩට බලන්න කිව්වම නිකම් මේක XX ESP එක දැම්මොත් එමේ එන්නේ මෙතන එන්නේ මේ ESP එකේ ඇඩ්‍රස් එක එන්නේ. ඇඩ්‍රස් එක කන්ටෙන්ට් උයි. මොකද්ද මේ ඇඩ්‍රස් එක? මේ F ටික අමතක කරන්න දැන්. F4ක් තියෙනවා මුලින්ම. ඊට පස්සේ CFF0 කියලා. ඒතර මම හරිම ඇඩ්‍රස් එක ලියා ගන්නම්. ESP එකේ ඇඩ්‍රස් එක තමයි guys remember මෙන්න මෙතන දාපු ටෙක්ස්ට් එකක් දාගමු. ලියාගමු මේක. CFF0 simple වලින් F4ක් මුලින් තියෙනවා අපි එකක් ලියාගමු දැනට අවුලක් නැහැ. FFFC0 ඔක තමයි ESP එක. මේක තමයි ESP එක. එතන මේ කියන්නේ මොකද්ද? ඇත්තටම මෙන්න මෙතන ලොකේෂන් එක ඇඩ්‍රස් එක FFF0 C0 එක තමයි මේ තියෙන්නේ. right? තවත් සරලවට ඇන්දොත් මේක මම වෙනම ඇන්දොත් මේක අරගෙන ස්ටැක් එක විතර මේකේ පළවෙනි පොයින්ට් එක තමයි මේ FF0 කියන්නේ. C0. දැන් මේකේ තියෙන අපි දුම් මේක 8 byte location එකක් කියලා මේකේ value එක මොකක්ද? value එක අපි බලමු. මොකක්ද මේ value එක? 41 41 41 41. ඒ කියන්නේ මොකක්ද? බලමු. copy කරගමු මේක. we'll go to the browser and say hex to decimal. Okay hex to decimal. කළා බලමු ඉස්සෙල්ලා අපි. hexadecimal to decimal. Right? We'll paste it here. Make hex වලින් තියෙන්නේ. We'll convert to decimal. ලොකු number එකක් වෙනවා. We don't need that. But what we'll do is decimal වලින් තිබ්බට value එක යන්නේ අපි මේක දාමු text වලට. Convert. Okay, hexadecimal to convert. So I'm going to paste it here and convert. Oh my goodness, what is happening? Let me check Unicodes. Okay, there's some problem here, no? But ideally, guys, this 41 is capital A. Let me check only, forget about 0x part. Let's face, okay, now you can see it's a A. Even I think ASCII also is same. ASCII in the math, A matama endi. You make a 41, 41, 41, 41 tibbana, A satarak endi. The 40 up to 42 තියෙනවා කියලා 42 42 42 B මේ තිබ්බනම් 43 40 sorry 43 0x එක අමතක කරන්න 43 43 C මේක තිබ්බනම් 61 61 කියලා ඉවරලා 61 ඒක simple එකක් 61 61 61 61 61 තිබ්බනම් it's like a simple layer. So what is capital A, guys? 41. I hope that is clear. So what you have here in the ESP is 4ක් තියෙන්නේ. So what do you mean by that? අපි AS දැම්මනේ අර මේ කෝඩ් එකට. ඒකෙන්ද මුලින්ම ස්ටැක් එකේ පිරලා තියෙන්නේ AS 4ක්. හරි. අපි දැම්මේ AS ටික පිරලා තියෙන්නේ ස්ටැක් එකේ. I hope that is clear. All everyone? හරි. දැන් අපි බලමු ESP එකේ ඉස්සරහට අපි ESP එකෙන් ඉස්සරහට බලමු. Meaning පස්සට වෙන්නේ නැත්තරම but don't worry, I will use the term beyond ESP. So that is through to the stack. I'm going to look for 50 locations. Examine. Right? I'm going to look for 50 locations, or you can look at 1,000 locations, but don't need no. I will look 50 locations from ESP. There may my EFC CFF0. CFF0. Sorry, I make among FF0. Sorry. Somebody has told me that as well. It's CFF0. Small mistakes is CFF0 onwards, right? So this is also CFF0 onwards. You have A's here and there onwards there are other gibberish. Other gibberish. මේ stack එකේ මේවා ටික තමයි තියෙන්නේ. මට මේක බලන්න පුළුවන් වුණනම් මේ hex වලින්නේ I can look at from ASCII. Yeah, ASCII වලින් බලන්න පුළුවන්. මේ A's වලින් බලන්න පුළුවන්, දැන් G's වලින් බලන්න පුළුවන්. එක එක formats වලින් බලන්න පුළුවන් මොනවද තියෙන්නේ කියලා. B කියන්නේ bytes. Right? Or පේන 41 ඒ වගේ තියෙනවා. But normally guys we are always looking at from hexa. අපි hex එක තමයි වැඩ කරන්නේ මෙතන, don't worry. So let's look at xg. Or let me clear the terminal, and again I will look 50 locations from hex. That's it. So because now we have not only 4 but 8 here, because this is 64 bits. But again, nothing to worry too much about it. Or you can even you can look for the RSP. value can't be converted. Okay, for the moment we can have to say xg. Okay, nothing to worry too much about. We'll go with TSP because it's 32-bit one, right? So no harm. Now we see the values here. Okay, so now we'll run it again. This time we'll add a little bit more A's and see what happened. Okay, so we'll get clear the terminal. Anything that is not unclear, let me know. Now purpose is මොකක්ද අපි දැන් purpose එක. Now මේක තියෙනවා A's ටික පිරලා තියෙන stack එකට. අපිට ඕනේ මේ stack එක ගිහලා පුරවගෙන ගිහිල්ලා අපිට තියෙන boundary එකෙන් එළියට ගිහිල්ලා අපිටම මේ දැන් මේ main එකේට එහා තව stack එක තියෙනවා ඉස්සරහට. දැන් පස්සට තියෙනවා. මේ stack එකේ ගොඩක් දේවල් තියෙනවා. මෙතන තියෙනවා password file එක. කලින් program එක load කරපු. මේ password file එක if we can override this one, I mean that's hacking. That's hacking. So we want to know whether we can go beyond number of A's and go into the program. ඒක කරන්න I'm going to do some fun stuff. So let's do this. Now Wonderbolt program එකේ අපිට A's 10ක් දාලා බලන්න පුළුවන්. Program exit. Nothing happens. But this get function එකේ ප්‍රශ්න තියෙන්නේ. I'll write the gets function. It has a buffer limitation. But the problem is it doesn't check those boundaries. Because of that, අපිට A's 10ක් දාන්න ඕන තැන we can even put 1000. අපිට මේක දාගෙන ගියා හැකි. So then we are actually changing the stack as we wish. එතකොට what we're going to do now, I'll get to Python 3 and I'm going to get several A's printed. ඒක මම lazy. Let me get 200 A's printed. Okay, now I'm going to use this 200 capital A's added to my binary program. Let's copy this selection. Even if I need, I can just paste it here as well for further usage, data usage. Let's now get back to this one. I'll exit from Python. I don't need it anymore. And then I'll run my Wonderbolt program. Okay, then I'll give this input. And oh, now you see what happened. Suddenly I got the message called I hacked you. වෙන්න ඕනේ වැඩේ වෙලත් ඉවරයි, flag එක print ලත් ඉවරයි, but I mean you don't understand what happened, no? So let's go one step after the other and then understand what had gone wrong in this program. So can you remember I created this flag called I hacked you? Now I can weave it, meaning something terrible has gone wrong, right? So let's see what is that terrible thing that happened. So what I'm going to do is I'm going to run this and I'm going to say yes, it will start again. Now they're asking for the input, no? So let me paste this. Oops, not again input, but rather these A's. I'm going to put 100 A's. I took 100, right? Okay. Now I'm in the breakpoint. Make my breakpoint at I'll get this I hack message. The මේ program now this is GDB debugger. So that is the value of working the GDB debugger. So now I can check the locations. Then මේ stack එක මට බලන්න පුළුවන් real time. This is a very powerful thing, guys, right? It's like magic. It's like magic. You can load anything into the computer and you can look at it. So isn't it magic? It's terribly magic, right? Right. So now what I'm going to do is I'm going to examine now. First I'll examine the EBP. Now I'm going to look at where is EBP. So EBP EBP is the bottom of the stack. At least in this Wonderbolt function again EBP don't worry too much. It's like the base, not the real අඩියම නෙමෙයි. මේ function එකේ අඩිය තමයි EBP එකෙන් කියන්නේ. මෙන්න මේක තමයි EBP කියලා කියන්නේ. එතකොට මේ අඩිය තියෙන්නේ බලමු D008. Guys, I'm not going to put this 4Fs. වැඩක් නෑනේ D008. Then බලමු. එතකොට මේක D008. So let's name it as D008. D008, right? So that points to this one. So it seems to be a bit of cluttered. So let's get a new one. අපි මේක සරල බඳගමු. අපි stack එක අඳගමු මුලින්ම. memory එකේ තියෙන stack එක විතරක් අඳිනවා. මම දැන් memory එක අඳින්නේ නැහැ. එතකොට memory එකට දැන් මම load කරනවා main routine එක. main එකෙන් Wonderbolt routine එක load වෙලා තියෙන්නේ දැන්. ඒක තමයි memory එකේ තියෙන stack එකේ තියෙන්නේ. This is the Wonderbolt routine. මේක තමයි වල් එක. මේක තමයි ප්‍රශ්නේ තියෙන්නේ. get function තියෙන්නේ මේකේ. So that is the problem, right? And මේකේ තියෙනවා two places. එකක් තමයි මේ base point එක, එක තමයි EBP එක. එතර මේක EBP එක ඊට පස්සේ එතන EBP point වෙන්නේ මෙතෙන්ට අනිත් එක තමයි දැන් data දාලා තියෙනවා ESP top එකක් තියෙනවා data දාලා තියෙනවනේ මේකට. එතන මොනවද data කියන බලමු. මේ data පුර වෙලා තියෙන්නේ මෙතෙන්ට වෙන්නකම්. හරි. Okay guys. So this is the main function. And the pointers EBP and ESP is maintained in the CPU. CPU එකේ මම sorry about my drawings. I need to use a pen next day. So you have the EBP. The EBP එක points තියෙනවා point ලා දෙනවා EBP එක අපි ලියාගමු මොකක්ද කියලා. ඒතර EBP එක ඇත්තටම තමයි අපි දැන් හොයාගත්තේ D008. Right? So it's D008. So let's write it D008. එතකොට D008. So that is this location. Sorry, so this location, right? Sorry. So D008 is here. That's a higher address, huh? Hope you guys can understand it, remember it. Right. Then we'll look at the ESP. එකත් අපි බලමු. හරි. ඒ වෙතින් content 4141. අපි දැන් බලන්නේ මේ content එක නෙමෙයි address එක. CFFF0 කලින් එකමයි. So text EBP නේ උඩ තියෙන්නේ ESP තමයි යට තියෙන්නේ. So ESP එක මොකද්ද? EFF0. මම වැරදි නම් මට කියන්න කලින් වගේ EFF0. ඒක point වෙන්නේ මෙතෙන්ට. So this is EFF. Of course D එකට වඩා E එක අඩුයි ඒකින්ද ප්‍රශ්නයක් නැහැ. Give me a second guys, give me a second. Sorry about it. So that's EFF0, right? EFF0. I hope it's right. You guys can make screenshots if you want to, or you guys can do it. Anyway, you'll get the video today itself, right? Don't take it to the next day. Video. Every day I'll go to video, put a video, you have to watch the videos and come to the next week's lecture, right? Right. Okay. Normally I don't keep the promises, but this time probably I will, right? So yeah, so D008 උඩ තියෙනවා EFF0 පල්ලෙහා තියෙනවා. Now at the moment now yeah තිවංක කියන්න බලන්න දෙකේම පිරලා තියෙන්නේ මොනවද? මේක විදිහට නම් දෙකේම තියෙන්නේ මොනවද මේ?
Ace.
Ace තියෙන capital Ace. ඒතර මේ පේන විදිහට අපි දැන් Ace ගොඩක් දැම්ම හින්දා අපි වෙන පාටකින් අඳිමු. මෙතනක් තියෙන්නේ ESP එකේ පටන් ගත්තාම තියෙන්නේ Ace. හරි මෙතනක් තියෙන්නේ Ace. දැන් මේක හරියද කියලා බලමු අපි. ඒක කරන්න අපිට තියෙන්නේ what we have to do now we'll print 50 locations from ESP. ESP නම් පටන් අරන් උඩට බලමු. يعني අපි ගමු stack එකේ බලමු මොනවද තියෙන්නේ කියලා. So මේක මේ අනිත් පැත්තට තියෙන ඕනද මතක තියන්න මේ EFF එකේ යට. යට ඉඳන් උඩට මේක යට උඩට පෙන්වන්න බැරි හින්දා මේකේ මෙහෙම යන්නේ මේ. මෙහෙම පල්ලෙහාට යන්නේ. මම පල්ලෙහාට යන්නේ බට් මේ පෙන්වන්නේ මෙතන තියෙනවා මෙතන උඩට. හරි. මම හිතන්නේ හැමෝම තේරුම් ගන්න එක ඕක තමයි තියෙන එකම පැටලෙවිල්ල. but මේක පුරුද්දක් වුණාට පස්සේ that's nothing to get yourself tangled with. හරි. Now we have things. Now just carefully look at two things. The first one is now CFF0 is here. Now we have Ace. Okay, that's good. So we have a control. මෙතන පෙන්නන්නේ we have a control, really good control, right? And then where is D008? කොහෙද base එක තියෙන්නේ? So that is basically D008 කියලා කියන්නේ කොහෙද? මෙන්න මෙතන ලොකු දුරක් නෑනේ. චූටි දුරක් තියෙන D008 කියලා කියන්නේ මෙන්න මේ හරිය කොහේ හරි තැනක. Right? මෙන්න මේ හරිය තැනක කොහේ හරි තැනක. So now the problem is let's weave it in a very different way. අපි W දාලා බලමු word. Yeah, so this is much better, right? So now this is D00100. So now what you understand is we have to get the difference between ESP. දැන් මෙතන තියෙනවා this is where ESB is base point එක sorry ESP එක and base point is somewhere here. right? So this is ESP starting point, and D008 is maybe before 10, no, it's somewhere here. So only what we need to fill AC is up to these points. මෙතනින් එහාට දාලා වැඩක් වෙන්නේ නැහැ, මොකද this is the stacked through. We can override if you know exactly password file is somewhere here, we can overwrite it. Otherwise there's no point, right? So now we try to do a bit of a change. Now how many A's here? Now up to this point, it's like 1 2 3 4 5 6 sorry 4, no, 1 2 3 4, no, 41 41 1. So this is 4 here, 4 A's, 8 A's, 12 A's, 16 A's, and then 20, and then how many? 24, right? And 28. So we don't need 100, we'll get 24 only. So balloon tricolor Python 3 again 24 is again. I hope you understand what I'm trying to do is, what I'm trying to do, I'll explain in a bit, but at the moment we are controlling the buffer stack that as we wish. You get 28, 24, that the 4 into 7 is 28. 1 2 3 4 5 6 7. I get 28 come. You get only 28 days. Okay, so now I'm going to run this again, guys. Rerun this. So they're asking, can you run from beginning? Yes. So let me clear the terminal. Okay, so let me run it again. Run it again. Now how many A's I'm going to print, Tivanka, here?
28.
28. Press enter. Perfect. Now what I'm going to look at? We look at the buffer first. EBP, sorry, the base pointer. Now you know base pointer D008. Now after A's make it. I'm happy. Right? I'm happy. Then look at we don't need 50 locations. Okay, guys. Now what had happened? Now we can see we don't feed all A's everywhere. So up to this point we have A's, right? So this is D00. This should be D004, and I think this should be D008 because my 4 bytes, no, this is 4 bytes, that is this starting point D004, this is D008. Now I just want to double check this is not the base pointer. So what I'm going to do is I am going to do some funny thing. Now I'm going to run this again, guys. Now see, up to this point there are A's. Can I put something else for this one and see whether I can override this 565? override. So this is the magic of wrong functions usage. So let me copy 28 A's and then print කරනවා. Right. B, 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 B. What do you think we'll print end of the day print at this location? In print not very good. So what will get printed here if we rightly print it? The B will hex code එක. Yeah. 42. Let's see. Let's enter this. Okay, now look at the base pointer. EBP. මොකද්ද කට්ටිය base pointer කියලා කියන්නේ? මෙන්න මෙතන. Right? මෙන්න මෙතන. EBP එකේ දැන් 41 තියෙනවා නම් ඒ කියන්නේ එතන අවුලක් නැහැ. 41 තියෙනවා. ඒ කියන්නේ මෙන්න අපි assume කරේ මේකනේ base point එක කියලා. Later we'll exactly know what is base point. Don't worry at the moment. මෙහෙම බලමු. There are a lot of commands to check those things, but අපි අර සරලම විදිහට යමු. Then what I'm going to do is I'm going to go from මෙතන ඉඳන් 20 shots බලනවා. අපි 20 බලමු. What is here? What is here, guys? So was I successful? Exactly. I now can control the full buffer. මට ඕන මෙතෙන්ට C's දාන්න, මෙතෙන්ට D's දාන්න, මෙතන තාමුණු හරි දාන්න. That all I can do. Without any problem I can do that. So what I'm doing here is I'm being very powerful. නිකන් අර God වගේ, right? So I can control the full buffer as I wish. Okay, guys? Is that clear?
Yes, sir, clear.
Okay. Now for the good stuff. දැන් අපි කරන්නේ මෙන්න මේක තමයි buffer overflow කියන්නේ. අපි දැන් buffer overflow කරලා ඉවරයි. ලෝකයේ මතන Google එකේ හැමතැනම internet එකේ හැමතැනම vulnerabilities are called the major vulnerabilities තමයි නැත්නම් exploit development method එක තමයි buffer overflows. Then you can be happy we have done that. We have done the buffer overflow. But buffer overflow කරන්නේ මොකක් reason එකකින් දන්නේ? What is the reason that you want to do a buffer overflow? Either to get the shell access, or either to go and get the root access, either to go and hack something, either to go and get the password. So now what we'll do, right? We'll go and look at our function. Then තමයි C code එක බලන්න අපි. හරි. Any problems up to this point? Chatura, Supun de Silva, right? So Udana, Aprami, I know some of you have done this. Niranjan, Isuru, anyone, any questions?
No, sir.
No, sir.
All right. Don't worry if you don't understand any bit, I'll get the video to actually go through. Right. Now go to the C program. Now this is the main routing, nothing to worry too much about it. At one place, it's calling, or they're getting the gets values, right? So this is like, as an example, give me the input. So it gets it, and see the size of the buffer is 100. We are now going beyond 100. ඒක තමයි මේ get function දෙන වැරද්ද. මෙතන තමයි function එකේ වැරදි තැන. This is the evil function. Stupid function, right? You can say all of these things. Stupid function, right? So gets buff1, and then we are calling vulnerable function. So this is vulnerable function. ඒකෙත් තියෙන vulnerable එකක් තමයි string copy එක. එතනත් ප්‍රශ්නයක් තියෙනවා. The two places we have the issue. But මම කරන්නේ මේ gets එක ගැන නෙමෙයි worry වෙන්නේ මේ vulnerable එකේ තියෙන string copy එක. මෙතනත් තියෙන්නේ vulnerable function එක. ඉතින් අපි මෙතන තමයි break point එක දාන්නේ. We are putting the break point here. අපි assembly level එකෙන් කරේ. Okay, that's fine. Now what happens is sorry. Give me a second. Yeah, that's what we did. No, yes. That's what we did. Give me a sec. Hello. Yeah. කවුද මේ පොත තාම ලෙච්ච ඔයගොල්ලෝ ඉල්ල දෙන්නේ? අපි විනාඩි 10ක් කරලා දෙන්නව. හරි. Yeah, let me check now. Yeah, I think we have done the hack truly. Now what we can do, give me a second. So I was actually going to access this vulnerable function, but anyway, it's been called now. So let's see, we put a breakpoint here, and after this, okay, where is this flag is called? Give me a sec. This is where the file is open. If it is null, print please create a flag. Okay, that's fine. That's all good. Okay, let's do this. Now what happens here is, now see, if we go logically, if there's a flag.txt in the directory, it will ask to create it. So we have already done that, so it will go through, and then nothing happens at this side. And then what happens is, they'll ask for the input, right? And then they call, they get the input, whatever the A's that we are printing in, they go here, right? And then ideally, if nothing happens, it will return. This function will return at this point, right? It will get returned at this point, and then program will exit. So there's a normal routine, and that's what happened all the time. If I can show you again. So this is what happened, right? So now try to understand. So this is a very simpler program. That's the problem, right? So let me exit out from Python. Let's run the program. right? So when I do A's, even like this number of A's, there's illegal hardware instruction that is there. So that is buffer overflowed. But if I give only 4 A's, what happens is, right, the program will exit. So what happens there? So let me show you. So if you get number of A's, it will send it to the vulnerable function. They copy, paste. That's fine. Copy to a different buffer. That's okay. I don't care about it. And then again, it will return and then program will exit. Now, what we should do is program should not return from the vulnerable function. And then what is going to happen is, so it will simply overflow and then we can get the flag out of it. And that's what happened earlier. So let's go and try that out. If you can remember, you have to get the right number of A's here. So we'll get something like this. Okay, no, maybe like little bit more here. No, probably a little bit more. Nope. Okay, we'll put 1, 2, 3. Okay. So how many is here now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 A's. If you put 22 A's, the buffer will get overflowed. So 100 buffer will overflow. Then we'll show the high hack too. So we have already done that. So we have overflowed the buffer. So 22, we have actually how many A's we had. So we can get 24 or 25, it doesn't matter. So now we'll do that. We'll do the same, right? So now we'll understand what's happening also. This knowledge will be very useful to do something fun or something more hacking oriented. Get 24 and then we'll print it now. Right? So let's do this. We'll run this, right? So previously, Tivanka, can you remember how many A's you printed up to ESP or EBP?
28, sir.
28, no? Okay,
Yes,
so
sir.
28 means we have passed the EBP. We come up to the EBP. And after 28, we had some B's as well, no? Right, anyway, we'll go with 24. And now we'll do it in a more of understanding, better understanding what is happening in the code level. Oops, what happens there? Copy selection. Okay, maybe let me do this again. Copy selection, run this again. Yes, and paste it. Okay, that's all good. Then clear the terminal. Okay, then we'll look at directly this one. So as you can see, we have come up to D004. So I think we need a little bit more, that is 28. Even this one, ideally, it should give out that flag, right? So because that's what happened in the real program. So now if I looked at the EBP, so ABP is having this value. So ideally, I have not overwritten EBP up to EBP, but whatever the problem had happened. So now what to do? Now let's see whether we can get the flag. Now we have already overflowed the vulnerable function, which was this, right, which was this function. Now we'll see, we'll move from this point onwards. Now, if you can remember, we are at a breakpoint. We are at a breakpoint. So what is the next instruction to be executed? We don't know. So we are going to say continue. All right. So that we have gone out from the system. And then let me see. Okay. Another C. And then we are continuing. And finally, we are having I hacked you. So meaning, basically, I have done my hack completely. There can be a few things that you don't understand here. That is how it really showed that the flag that at the moment, don't worry. So what I can do is I can have a little bit of a fun here. So let me go exit out of it, right? And we'll do another program which will give out the full details. Let me look at the flag and let me add something different. We have hacked our first program. All right, you hacked our first program, and I'll add it to the flag.text, right? Flag.text. You also can do that, right? No such flag. Okay, where am I? Flag.text, flag.txt, right? Can't be override it. Sorry, not cat, right? To be echo. We'll echo this to and redirect to there. So if I do that, of course I can leave what is in the flag. I'm not going to do that. I will do it here. Let me run again. And let me paste our A's. Oh my goodness, I'd run it again. So where is my 20 A's? I need my 26, so it's okay. I'll print it. This amount would be more than enough. And continue and continue. Okay, now we can see we have hacked our first program, right? Okay, guys. Now hope you have got the base idea. Any question up to this point? There are going to be a lot of questions in your mind. It doesn't matter. We have to do this several times again and again and again. Right? That's how we can really work it out. Okay. Any questions up to this point? Because we are not going to stop now. We are going to do a more fun type of activity. This is okay. This is good. This is the first one. But we'll try to do a more of a serious one, and we'll stop for the day. So don't go. I'm going to have a small break, and then we'll come back, guys. So let's do this now. So that's still a simple point to do. Another point to do, that is, now we need to submit this to PicoCTF and then get their flag, and they have to submit the flag here. That's how you get the marks. So let's this is the simplest one. No? So let's paste this. Oh, what happened? Okay, let's again go here and get this netcat. Oops. Copy. You come to this one and paste selection. Okay, input. So you have to do the same here. Nothing more. Okay, that's it, guys. Very simple. So this is the flag. Maybe the whole thing. I think everything is the flag, right? See how simple it is. But remember, there are very, very difficult tasks ahead of us. So let's go to the browser and paste the flag and submit the flag. Oh, you can see we have got 100 points. So buffer flow 0, we have solved it. Yeah, of course, there are 7,000 other people have solved it, but that's okay. And later on, we'll do like things like this function override. Only less than 700 people solve it. So we'll solve all those things. And of course, when you go down, there are more complicated ones. So we need to solve those things. Only solved by 14 people. So those are the ones that we need to go through. Okay, guys, are you clear? Supun, are you clear, Supun? Yep. Sivanka, are you clear?
Yes, sir, clear.
Perfecto. Right. So there are a lot of things, and of course, there are some ones where I have to start the instance, and they will give the program and everything. So this is the next level, actually. Let's go and get this next level code quickly and see whether it's something that is fun to do, or else I'll give you a different activity. Okay. Program. I don't want that. I want the source code. Open with Vim. We'll select mousepad. Do we have mousepad here? Okay, we have mousepad. Select. Okay. Yes, this is the one we have to do. So second one, we'll do this. So guys, now carefully, I'll give you a bit of a time, and then I'll do this with you. Go to the browser, PicoCTF, PicoGym, and select buffer flow 1, and then get this downloaded. You can look at the program if you want to, no harm, and start hacking it in. Okay, Can I give you like 10 minutes, guys? So it's 4:20. Can I give you 10 to 15 minutes? But guys, please, please, please try this out. If you have a lot of issues, don't worry. I'm going to give you the video later on. You can try it. So you can at least try a few things at least. And you can see what I'm going to do here step by step and learn that second one as well. Then you have to do it again. Otherwise, you will never learn it. So is that clear? Udana, Tivanka, can you try this out? Subhangan?
Yes, sir. Sure. Sure.
Yes.
Yeah, so I'll give you like 10 to 15 minutes maximum. Huh? Work it out. Okay. So I'm not going to leave the session. I'm just going to mute myself. That's all. So we'll meet in 10 minutes, right? Don't leave, guys. Don't worry. It can be very hard, looking very hard, but not really hard when you do it several times. Niranjan, are you catching up? Again, if it is hard, don't worry. You can start from the scratch and do again and again.
Yes,
and
sir.
again. Yeah, so start working on the buffer flow 1 in Pico. Right, guys. I'm going to mute myself for a moment. I'm going to have a tea. You guys also prepare a tea and come, but please do it. Then I'll show you how to do this next one. Thanks. Hope you guys are still there. So can I give you 5 more additional minutes? Ivanka, are you working with the problem?
Yes, sir.
Yeah, thanks. So probably I'll give you a few more additional minutes. I'll give you 10 additional minutes, and 4:45 we'll catch up again. Oh no, 5 minutes is enough. No, we have been there for almost 15 minutes now. So 4:40 we'll catch up again. So try to do, no? Thanks. Okay, guys, so let's start then. Any questions before I go into the challenge? Anyone? Chatura, Supun, Udana, questions? Apirami, any questions? Okay. All right. Okay, let's now then start. We don't really need the source, but let me download both. Let's go and exit from here. So we have done with our say quit, GDB say quit. Okay. So go one step back. We'll create, this is buffer overflow 02. So we go there. To okay, that's fine. And this guy also will make sure what happened. Okay. We go be over 2. Yeah. So for the moment, yeah, good. So there's nothing here. So we'll do a first wget. And let's paste the link. Okay. So we have our C code. So of course we can mousepad this. Yep. So this is a new one. So let's make sure that okay, we don't have anything else. So let's open this up. So yeah, there are 2 programs. So basically they'll close this one, save, and this is a new program. So if you can't see things clearly, let me increase this font a bit. Select font. We'll put it at 14. Okay, so now same program, please enter your string. It calls vulnerable, which is this function, guys, and that's it. So if you do it right, or if we do it the normal way, okay, time to return, fingers crossed, that's it. And it gives out the location where I get returned. That's all. But there's this other function called win function, which seems to be fun. And this is a function that the main program never calls. As you can see, it doesn't call win. So this is a secret function. If we can execute that, it will execute the flag. That's what we need. That's what we need. So now we know a bit about the program. I went through quickly, but because I'm going to go through it again and again. Okay. Now let's move to the prompt. Let's clear things out. And then I need our code. I can weave the code, copy the link. Same setup as earlier. Nothing much, nothing big. Get this one. Yep, all good. Okay, we have, oh my goodness, I got the same one. Okay, remove, I don't need vulnerable. I need to keep it clean. So now I have the C program, that's fine. Even I don't need the C program. Let's at the program. Yeah, let's copy link very clearly. Go here and wget that file. Finally, okay. Now we got it, all good. So we'll do the file command and see what sort of binary is this. So again, 32-bit guys, 32-bit, not 64-bit. We'll hack 62-bit later, ELF. And this is Intel 88, whatever. And least significant bit, dynamically linked and not stripped, which is important. We'll check sec, same. In your one, if check sec doesn't work, you have to download or install Pwn tools. I'll explain how those things later on, don't worry. I'll make several videos on this, how to install some of those tools. Or you can just simply apt install, you can install checksec. And see, everything is disabled. This is good. If it is enabled, like in the previous case, if you can remember, it's not that good, meaning I've had to do a lot more work. So this is 32-bit Little Indian and everything. These are called actually stack canaries, NX, PII, all are actually ways how can prevent stack overflows, buffer overflows. But everything is disabled, which is good, right? So it is good. It's like we want to get into a house, no locks, no windows, nothing, right? So This is the easiest thing in the books. We are doing very simple things here, guys, but don't get disappointed because we have to learn things first in this way. Then we have to go into the harder ones or the harder jobs. That's how everything works now. Right. So now let's see what's here inside. So we'll do a read ELF like in the previous case and see any additional fun functions. So this the main routine is there. It's in the, now we know address is this, the stack address. And then of course, we have the vulnerable function somewhere, this one, it's here. So I'll make sure that I'll get a copy of this one. So these addresses, it's good to keep these addresses. So I'll go to mousepad, let's create a new, and let's save this in our folder, right folder, which is buffer flow 2. And this is the walkthrough or write-up. So try to understand later on, we can even upload our write-ups to Pico CTF. So the vulnerable function, the address is this one. This is all hex, right? It's all hex. So let me just take only this part and we'll put it as 0x. So that is fine. So maybe I can extract only that part and say, okay, like that. That is good. Okay. Then of course I need, okay, where was I? Okay, I don't need the main function truly, but I need this win function. This is the function that I'm going to hack this time. This is a real, the previous one was a real hack, but this is something that is really tangible. So let's take the win function here and get the address. So those are the two addresses. And now we can get idea what are the functions that we need to use and the addresses where it represents, right? So this is again 0x. We can put 0x here. Okay, that should be 0x. Right. Okay, all good. Hope this is clear up to this point. Let's move on. So now what I'm going to do, let's now have a little bit of a fun. Now, let's first of all run this one with a GDB. I will use the tag previous as GDB1, but this use -q. Simple reason is then I don't get all those unnecessary stuff in the beginning. Right, now what's the first thing to do? Devanka, what's the first step that I want to do? You can remember from last time. Yeah, someone?
Set the disassembly flavor to Intel.
Yes, disassembly flavor to Intel. That is the first task. Yeah. Then what we do is we look at the, okay, we look at info functions again, like in the previous time. Write this down, guys. So you can have the main function, you know, and vulnerable function. So we'll take a copy of this one and see if it's the same that we figured out earlier as well. Now I'm doing it in rush, but when you're doing it, guys, keep it simple and see whether what are the other functions. Init take a gets, f gets, everything address gonna about that gun. The very I'm like subtle things, right? These are subtle things. So you have to do it in a way where you'll understand everything. So it will take a bit of a time. Don't worry. Give that time. Take things slowly, right? So anyway, as you can see, it's forget about 804 part 91F6. Yes. And this one is 804 9281. Oh my goodness. Is it different? Oh, no, 9281. That's fine. Same thing, vulnerable function. Okay, so I'm happy. Let's move on. So now I will disassemble main. Truly, I'm not going to work really hard with the main. Yep. So let it go. And I'll disassemble vulnerable function. And that is where all the fun happens. So truly, so there is one, right? So let me check. ESP printf get return address. Okay, there's a get call here. Okay, we can put a breakpoint to here. Then thereafter, there's this get return address thing coming in, and a lot of other things happening. Yeah, no, we can do it to the same level, no harm. But before that, we'll run this program. We haven't run the program, so only thing is now we have to set the chmod plus x to 1, right? So now we can run the code. So let's run this. Please enter a string. Of course, we'll start small. Okay, time to return, fingers crossed, jumping. So that return address is shown. Don't worry about this thing called return address. Now we'll run it again. This time we'll give a little bit more A's. Like hundreds. Okay, there was a seg fault. Which is good. Right? So that does mean we have overflowed. I think overflow automatically. Now we have to control it. And you can't go and say, you overflow again, nothing. Okay, you can say that. Now see, address is overridden. Me. Jump in address at overwrite anything. That's fun. That's all fun. So we have achieved whatever we want to achieve it. Right? Okay, 44. Somebody said, so Timanka said 44 is the number. Perfect. But now see, the point is now return address also all 41s. That is A's. We have achieved it. Now we'll do it programmatically inside the GDB. Because that's what we'll do. No? We'll do things in a way where we have control. Right. So let's do this now. Now we have set a breakpoint. So let's again disassemble this. So I'm always making it wrong. One, we'll put it here, 65. So how to put the breakpoint? Break star. So there are many other ways to do this. You can directly give the address if you want to. But yeah, what to worry. So I'll give it in this way. There are multiple ways with the plus, and it's 65. Okay, that's where the breakpoint is. One breakpoint is enough. Now, what if I try to print EBP now? Now let's do it and see. EBP breakpoint. Now remember again. So go to, I'll get a new stack here. You can add program draw this. When api danna stack upside down. The main root in already call kala tiyenne. Main call kala tiyenne. Right? Then we have called a vuln, right? We have called vuln. Now EBP current EBP අපි කියමු දැනට ඒක බොරි වෙන්න එපා. Current EBP එක තියෙන අඩියේ එතන EBP එක තියෙන අඩියේ. So we have it here, and then EBP, the top of the stack is this one. So that is the ESP. So now ideally I have started filling A's from this point onwards. Now අතරම EBP එකත් A's පිරලා තමයි තිබ්බ return address එකේ. Okay, that's what it is. So I'm not going to write down the addresses at the moment, but let's see. Okay, now if I type it, okay, now see I did XEBP, registers null. What do you mean by that? Can someone tell me? I have looked at EBP now. Why it is the case? Can someone please tell me? Aprami, why there's no registers can be seen at this point? Someone please tell me. Because guys, we haven't run the program or ran the program, right? We didn't run the program. All right. Right. So that's the problem. So we'll run this now. Yeah. So they're asking for a string. So Tivanka said we need to have 44, I believe. So let's go to Python and print. You can do it without going to Python like this if you want to. Let's try it out. Oops. Oh, okay, sorry. I didn't type it right. Oh my goodness. Exit. Yeah, now all good. So I can say Python 3 -c, and I can it should be, yeah, with a dollar print. Maybe I should have a parenthesis here and print A's 44, and that's it. Oh, that's problem. Python dash is the command line. What is the problem? Anyone with no speak on Python? Can you tell me what the issue here? 44. Is it this one? File string line A is not defined. Oh, okay. And,
So I think print should be without the parentheses.
print should be
Outside of the parentheses.
outside the parameter. What do you mean by that? Okay, there's somebody has printed it. Print C, print. Okay. Okay, maybe the dollar is not needed. No. Print Okay, let's do that. Okay. Okay, not that. Can someone please help me quickly? Resistance, that's okay. This is Python 2, that's the problem. So Python 3. So yeah, I can just search it. But anyway, so you guys can do it, but let's do it because we started it. We should finish whatever we started. Python script to print is. That is a very common one. So I think we'll get the answer. In the command line, in with -c. -c is the command line. Okay. Yeah, so this is Python C. Yeah, that's all good. Okay. Not what we need at the moment. It's not there. Okay, this is I think Python 3, no? Print, okay. That's fine. So it's a single bracket. And yeah, I didn't find it. Anyone found it? Print its source. Okay, let's see Python print in the terminal. Okay, somebody has figured it out. This works. Okay. Okay. So how did you put Python in the terminal? Is it just Python? And in the full command. Print 10. Okay. Yeah, anyway, I will not waste the time. You guys can figure it out. If you found it out, let me know, right? So Python print, okay, let's do a one single try and see if it works. That's fine. Otherwise, it's okay. I will continue with the rest because what is important is that you hack this, no? So Python, I think, yeah. Python, see, Python. So it should be originally Python. What happened? Sorry about it. Okay, Python -c, then we'll print this. Oops. So yeah, print. That's it. And okay, so we can use single quotes and 44. No, that's some problem. Anyway, we will work out it later on. Not need to worry. So we get 44 Python is, that's fine. Sorry about it. Okay, should be Python 3. Right. And then we'll print 44 of them. That's much easier. All right, now we'll paste this one or copy this one. Now we are all good. We'll paste this one and right, we are on a breakpoint. So so jumping to this location. So we know the return address was not being overwritten. So let's clear the terminal. And now we look at first the EBP. Oh, that's great. EBP has filled with A's. And let's look at 50 steps from ESP. Okay, I might have to fill that in. So let's do X50X, examine X4 examining on ESP onwards. Oh my goodness, this is fun. And so this is 78. So 70, 74, 78. So we have filled all A's here. That is perfect. And this one, there's nothing. So we'll set some B's now. We'll run again. Run again. Yes. And this time we'll fill the A's. And oh, sorry. We'll get this one copied again. We'll paste it here. Okay, I don't think I have copied it right. Paste this here and with 4 B's. Ah, that's good. So this is jumping 40, 42, 42. Now let's look at this one. Yes, we have overwritten that. And this also 4042. Now we go to the code. What do you mean by this? Jumping to. Now once you go here to the C code, now what you are seeing here is get return address. That's what they're printing. You know, what is get return address? Is there anything here? No, guys. That is coming from this header file called get return address. So what is this return address? This is the next most important thing you have to understand. If you understand this one, rest is simpler. So the idea is this, guys. Now, now in the morning, you go to office. What is your return address? So you have to know to go back to your home. Depression you go to temple, you go somewhere else. Return address. Right? So that happens a lot. Right? So you have to remember where you came from. So normally in the main function get loaded here. So ideally now somewhere here, you are loading the next function. You're jumping from here to here. And then you understand where to jump back. And that is called return address. Okay. We'll analyze this later on a lot deeper. And මෙතනින් තව කෙනෙක් activate වෙනවා නම් ඊළඟ එකත් stack එක load කරන return වෙන්නේ මෙතෙන්ට. මේ function එක ඉවරච්ච ගමන් ඊළඟට return මෙතන දැනගන්න ඕනේ. Right. So now we look at the stack with the return address. EBP, return address, and probably ESP. ඔය ටික කොහොමද තියෙන්නේ කියලා බලමු. හරි? You get a picture. Okay. Now this is the important part. Then බලමු මේ image එක බලමු. Is there a better image? No, this is good. No, this is much better. Right. We'll get this image. Guys, මෙන්න මේක හොඳට ඔලුවට ගන්න. දැන් බලන්න මොකද වෙන්නේ කියලා මෙතන. Main function එකෙන් foobar call කරනවා. Foobar return වෙන්නේ මෙන්න ඊළඟ step එකට. මෙතෙන්ට තමයි return වෙන්නේ. ඊට පස්සේ if there's another function here, තව මොකක් හරි code එකක් තිබුත් ඒක run වෙනවා. Now we'll look at this one. Then what happened? High address මේ stack එක අනිත් පැත්ත හරවලා තියෙන්නේ. High address කියන්නේ මේ පැත්ත, low address. මුලින්ම memory එකට main දානවා. Main දාලා I mean like you are jumping to the new function. මේ blue color එකෙන් new function එක. ඒකේ EBP එක මෙතන තියෙන්නේ. So once you finish completing this function, you have to return back to this place. අන්න return address එක තමයි තියෙන්නේ EBP ට පිටිපස්සේ. එතකොට EBP +4 click කරන මේ පැත්තට bytes 4 මේ පැත්තට හැම විටම අපේ function current run වෙන function එකේ return address එක තියෙන්නේ ඒ current function එකේ EBP එකට byte 4ක් 32 bit නම් byte 4ක් පිටිපස්සේ. ඒ කියන්නේ මොකද්ද? ඒ කියන්නේ guys, if you look at our buffer now, this is where is our EBP? EBP කියන්නේ D078. So D078 කියන්නේ මේක 70, මේක 74, මේක 78. මෙතන ඉඳලා +4 කියලා කියන්නේ මොකද්ද? This is our return address. ඒ කියන්නේ ඇත්තටම කිව්වොත් එහෙම 70, 74, 78. එතකොට අපි බලමු ඇත්තට මේ ගහලා බලමු XX මොකද්ද කියලා. XX මේ කියන්නේ EIP එක මොකද්ද කියලා බලමු. EIP. Oops, sorry. What did I type? Okay. So currently what we have is some value but the true location is okay, what is that? I think there's something wrong there. 804. Okay, that is vulnerable functions return address. Yeah, that's fine. What you're having here, the value here is fine. Currently this is what is there. But truly now the real EBP for the current program resides next to this value. So because this is the EBP, right? EBP is this one. So let me actually I have to print EBP, right? Not EIP. So this is the location. See, D078, which is this one. Next to this one, 4 bytes next to this one, you have the return address. If I fill this value with whatever where we want to jump, so it will jump when you run the program. Okay, let me clearly put it out. Now you know the location now. Let's try to draw it in a new diagram. Let's first copy this. we'll copy this bugger. All right. Give me a second. You guys can have a quick break. Give me a sec. Okay, so sorry about it. So give a sec. Okay, now what we'll do now, carefully look at this. This is the most important part. So we'll go to the whiteboard and we'll draw it again. So I think I can't paste that one. Why is that? So I really wanted to copy this. Can't I paste it here? I just say, okay, gotcha. Okay, now this is what we understand. So let's draw this. So now we'll draw the same stack here. So this is the stack guy. What happens? Okay, so then yeah, that's more like it. And then what I'm doing is like, so this is the main is loaded, and then vuln is loaded. So this is vuln, this is vuln, right? So vuln's EBP is here. This is EBP. So this is the saved EBP, and ESP is here. So now if you look at the figures, the values, you can see current EBP is in D078. Okay. Oh my goodness, what happened? Anyway, it's okay. D078. So that is D078. And now, of course, next to this, sorry, D078 is the address, right? Sorry, is that, and the values you have here is all 4141, all A's. Next to this, you will have your what you call as return address. This is the return address. So currently there is some garbage values filled in. See, there are some values here. Not garbage. I put B's, no, so it's B's value there. So I want to now put something here. Now we'll understand how to put and what to put. Okay, now let's. Okay, it's there. No, still there, right? No worries. There was no quit happen, which is good. Okay, now this is the situation now. Now, where do you really want to jump? This is where the magic happens. Tivanka, are you there now? You there?
Yes, yes.
Okay. I think others are also there listening. Rohana, Ramesh. Right. Now let's look at this one. So we have our A's all lined up. So let me copy this to my mouse pad for the moment, because all the magic will happen here. So this is the string. So that's all right. So then what I'm going to do, now I want to jump this to the win function. Now, if you can remember, this is where all the function happens. But this is never being called. It's a secret function. But can we call this guy? Win function call karane kohomada? Guys, it's so simple. How? Can you remember? We have a hex address for the win function. Now we need to add this here. And how do you add it? Again, quite simple. So we have to just add this directly here. I think my paste did work, right? But there's a small issue. I'll tell you the small issue. There's this two format. This is just a hex number. No? There's a format that we need to type things in. This is normally, this is in big Indian. We need to type this in little Indian here. You'll not understand this, so don't worry. Only change is every byte should be reversed. So better bytes හතරක් තියෙනවා. 80 කියන්නේ sorry 0.8 කියන්නේ එක byte එකක්, 0.4 කියන්නේ එක byte එකක්, 91 කියන්නේ එක byte එකක්, hex bytes. 46 can, sorry, F6 can a byte. So what you're going to do is you're going to reverse it. So ideally F6 should come first, and then you should have what?
91.
91.
04,
Then you should have
08.
04. Yes, thank you. 08. But there's a small addition because these are all hex bytes. You have to say it explicitly. So you put dash X in the beginning. Okay. So if you don't really understand email with formatting, and don't worry, formatting, no, nothing big. So then we have A's, and අපි මේක එකතු කරමු මේකට. මේ strings එකතු කරන්න මේ විදිහට. ඔය විදිහට දාන්න පුළුවන්. මේ විදිහට අපිට statement එකකට හදන්නත් පුළුවන්. Or else I think this should also work. We'll take the full string because you're copying the string, no? We'll put it here, and we'll take this value, and we can of course verify whether it works. So we'll take the full string here now, and let's see how the magic happens. Let's go to the prompt and we'll run this again. So let me clear the terminal. Let's clear the terminal, Okay, run this again. Yes, let's paste our new string. Seems all right. Okay, fingers crossed, jumping. Oh my goodness. It's a breakpoint. Let me see. XX, is there any problem? Seems no. Okay, now, oh, there's a problem. What is the problem? D0. So this is D078. That is this guy. But I don't think it worked out properly because the problem, I tell you, it taken these values as something very different. So how can we work it out? Ooh, let's see. Let's think. So this is not the way to do it. So then I think we need to print this to a file. How to do that? Let me figure it out. So the easiest way to do it is from Python, we should print it. So let's print, let me see whether we can print 44A's here. No, let me check whether we want to do it like this. Nope, this is parentheses. Missing parentheses is called print. Did you mean print? Okay. So this is the problem with Python. Not a problem, but Python 3 needs this, no? Okay, that's fine. Then can we plus බලමු මේක වෙන්නේ කොහොමද කියලා plus අපි bees ටිකක් දාලා බලමු. එකතු කරලා බලමු bees 4ක්. දැන් බලමු. Oh, what happened? BBB is not defined. Okay. හරිනේ ඉතින් මේක we have to put under quotations. That's fine. So let's clear the terminal for a moment. Again print it. All you guys are okay, no? දැන් බලමු නිකන් මේක dash 0 64, no sorry, 0x. අපි දාලා බලමු 41 එකක්. No, that's another A. Sorry, 42 එකක් දාලා බලමු. That works. Perfect. And then we put another 43. Nice. X44. D. And put another X45. Yeah, it got printed without any problem. Now what we have to do is we'll do the most needed one. So we'll take the copy of this one. So this is what we need to print. We'll print that. Yeah, all good. So only thing you might wonder why the values are not printed, because I mean, we don't know what are the values. So that's how it works. Now we need to run this in the command line. And I don't think this will create a file. No, you can't do that. You can't echo it back. So let's get this Python 3 thing. It works out proper. Let's go out from this. Exit. Okay. Let's try Python -C, and let's print this and see what is the problem. Unknown file attribute. That's fine. I think we can do a dollar here. Nope. This is what we need to do. This one we have to somehow figure out. Let's see. Give me a second. I think I had it somewhere. This particular command. Okay. The easiest way to find would be, let me see, workshop. Give me a sec, guys. I'm working for it. Okay. If you found it, let me know, please. So it won't take a long time, but let's see. You just want to print some strings. That's all we need to do. So there's a small syntactic error. That's, I think we can work it out. Somebody found it. Yeah, working on it. So this is the reason why you should learn a bit of Python as well, right? Not bit, actually, truly you have to learn a lot of Python. Give me a second. I think I had a file. Okay, I have it, I think. Give me a sec. I'll open it up. The command should be. Yeah, so. Yeah, in Python 2, you can do that. So this is the structure of it. So let's do Python 2. I think Python 2 is installed here. So that's nothing much, right? So Python 2. What the hell is happening? Yeah. Yes. Okay, there should be a hash. That's all good. 44. Okay, and just give me a second. Okay. Yeah. So this should be also double quotes. It's 8. Okay, that seems fine. So I think we should be able to print this. Okay. So we have a file called print. Let's cat the print. Oh, that's good. So we have done that. So this is the command, guys. So I hope that you can clearly see it. So Python 3, there should be a little bit of changes. So that's all right. So what we need is to get operated. So now what you do is you can run the code inputting this guy into it. So as an example, I can just say print. Okay, let's see. Okay, now we look at the memory. Oh, beautiful. So is this where we want to be? Let's check. This is the place we want to jump. Copy selection. And let's check this with the win, guys. Oh, yes, it's the same exact. Is that all good, guys? Tivanka and others?
Yes, sir.
Okay, it seems all good. So now our return address is overwritten. So now ideally, when we run this to the next point, the vulnerable function will go out, right? So now we are in the vulnerable function, right? So next instruction is load this one. What do you mean by loading this one? Right? So the next instruction is this one. So the return address is that. So once the function is returning, you understand, no? Return address. So we have looked at it. So where's that logic? Return address. The function returns. Return address goes here. So return address is this one is your win function, guys. Win function. Let's look at readdlf. Yes, it jumps to win function. So this is the win function. See, this is what we need to do. And if you look at the code in the win function, make a secret function. Win function ගියාම එයා බලනවා flag එකක් තියනවද කියලා. නැත්නම් හදන්න කියලා කියනවා. එනිම කියයි. දැන් මේක කියන්න ඕන හරිනවා. flag එක තියනවා, flag එකේ තියෙන එක පෙන්නනවා. Now let's see. So what you'll do is now to continue. Breakpoint again, you have to say continue. Let me clear the terminal. Let's see, guys. Thumbs crossed. Ooh, it works right. Please create the flag.test in the directory with your own debugging flag. I'll do that. There's no flag here. Let me echo. I'm happy. We've done it. Done. And create a flag.txt. All good. So let's again, we'll run the whole thing. Okay, let's continue. Oops. That's all good. Are you clear, guys? Is that
Yes, sir.
clear, everyone?
Yes, sir. Yes.
Okay, so now we have came from 0 to 1.1. But we have, this is called return to win. I mean, like if you ever heard of it, this is a classic buffer overflow. If you have a secret function somewhere, now we know how to hack it. But remember, you have achieved a lot today. You achieved a really lot. And we are going to continue on this. I'll make sure that all the videos are in the order. But now let's not forget about our Pico, right? So now our instant has been already run out because they are going to run a new instance. So we'll do that. We'll remove all the unnecessary ones. We don't need this or this or this, right? So yeah, now it's running. So this is a new address, and then there's a new port as well. So of course, you know, you have to run nc netcat. So let's copy it again. So what you do now, go back here and we'll test it here. Okay, so nc and paste. So there's a new port, as you can see. Enter. Okay, please enter the string. So guys, we can do this. Okay, nothing happened. So now we need to do this in a different way. Now we can create a flag here. ls. Okay, flag is already there. We don't have to create a flag, but we need to enter that value here. Okay, now how we should do now? Okay, this is what you can do. Now we need to enter our information directly to this exe. right? So this is a running one. No. So what we do is, let's get that print function. Did I copy it somewhere? Oh my goodness. Did I copy it anywhere? My print, where's my print? I think it should be there, no? Not this, not this, not this, not this. Oh, okay, this one. So this is what I use now. So what I'm going to do is, I'm going to take this one again and give me a second. I'm going to take this one again. Sometimes the remote things might not work. You have to be very, clear on these things. Don't worry if it didn't work out. We'll take time and do it. The remote hacking is a bit different, right? Bit different. So I have this one, which will automatically generate that byte string. So let's forget about this one. Okay, so it generates that. Now what I'm going to do is get it, and that output should go to this guy. So let's see how whether it's working. So this is the running exe. Paste it here, and now we'll do that. Oh my goodness. So now did you understood what happened? So it ran and it got these letters in, or this string in, and it jumped to the flag, and I got the flag. And don't you think it's magic? So we have hacked a remote computer and got the flag. So truly understand, this is a remote computer, right? In somewhere in the world. So let's go now here, and we'll enter this flag and submit the flag. Guys, that's great. So we got 200 points. And of course, there were only 3,000 people in the world had solved it. And I'm one of them. I'm happy. You guys also should do this. So see difference. The previous one, the first one solved by 7,000 people, but this one only 3,000 people. So then you can see next day we are going to do 2, 3. You can see it's getting decreased, meaning they are difficult, right, guys? Now I hope you got the whole point. Let me, every time, whatever you do, please document them. So I'm going to document it here. Final flag function, and paste it here. And it's always a good practice. I have learned this from John Hammond. You can watch his videos as well. He is doing the same videos. He's always copying his flags also. I thought, okay, why the hell you have to copy the flag, but it can be very useful at one point. All right, so that is there. So let's close this up, and let's close this one as well and save this. And I'm happy. I don't need this anymore. Collapse the subterminal, and let's quit from this one. Yes. And we are in the prompt, and we don't need this as well. Okay, that's it. And yeah, so leave this web as it is. And yeah, that's all about it. So give me a second. Okay, I'm going to, you can, if you have enough space, you can create a snapshot. You'll have all your information. But anyway, I'm going to suspend this VM now. Okay, now any questions? Now the question time. Yes, guys. I know it's being long 2 hours, almost 2 hours. Not really long, right? But still, I believe that you have gone through the basics, learn the basics of how to hack. All right, guys. So any questions? Any questions? I hope you have learned something. So now expect continuously series of other lectures on this. But please, like, watch the videos again. Otherwise, you will miss few things. And there's a lot more to learn. And especially OHTS students, PTS students, and ESIS students who are here, we'll be getting these things for the exam as well. So it's part of your lesson plan as well. So make sure you seriously learn these things. Yeah. So any questions, guys? All good. There's nothing to clarify.
So can binary code can hack any system?
Come again, Timanka, මොකද?
Like can this binary code hacking system literally can hack any system?
Yeah, why not? Can hack any system in the world, even a satellite. Only thing,
Okay.
guys, remember, it should be step by step. Now, when you talk about the new Windows system or Linux systems, they are preventing most of those things. As an example, you can change the stack, but there's an option not to change the stack. It's likewise, and then there's options to prevent injecting code. Likewise, so there are so many newer options coming in, and there's something called stack canary. I'll teach you about these things as well. So there are multiple ways to prevent this, but again, what hackers do is always find another solution, right? So anything that we understand in the world, the way how it works, can be hacked. There can be difficult things to hack, but can be hacked. Yeah, that's why, like, you go and read the hacker news. Every day there's a new hack. It was not there earlier. So I'm like, this is how it is, right?